Assalamu alaikum everyone. Welcome to Mathematics with Shahab Yaqub. So now tomorrow is the big day. Tomorrow is the day in which inshallah ta'ala you will all be performing to your level best, and dua for all of you, prayers for all of you, so that you get a very easy, very manageable paper, and may Allah give you the strength to manage such a paper. So the purpose of today's live stream 360-degree overview is that let's go over all the topics. And the way in which I'm starting is this. That is, let's break it up into components. And naturally, I won't overdo it. At the same time, I want to have a good overview. So the first breakup would be about differentiation and integration. That would be the part one. The second part would be about quadratics, and then circle, which is part of coordinate geometry, and then function. That should be the second part. And the third part should be about coordinate geometry straight line. Yes, that comes in a little bit. And of course, it's part and parcel of other things. And then there is series, which is AP and GP. Actually, I can transfer this to the very end. And let me write over here a circular measure and trigonometry. And maybe let me grab circle from here. And let me write circle with the coordinate geometry thing. So this is straight line plus circle. So these would be the four different parts of today's class. I'll try not to exceed more than 3 hours. So let's say this might take around like 40 minutes. This is just an estimate. In maths, you study estimation and approximation. So that's the real life example. So estimation is 40 minutes for this one, approximately 40 minutes for this one, approximately 45 minutes for this one, and approximately 45 or 50 minutes for this one. And maybe it would alter a bit. So might be, I think it's all balanced out. So now this is the part one of the journey. Let's start with this. I'll try to go over the concepts. So that is the first thing, that is concepts. Second thing, consolidate those concepts with the help of past paper questions, which will be already solved. I'll go over it because that's the best you can do in like 3.5 hours. And then tips and tricks for the exams tomorrow. So tips and trick. And it will come in between. So technically, it's just about that concept overview. But as I've named it, this is a 360 degrees syllabus overview. So now let's get started with the idea. Let me go over here and let me first focus on differentiation. That's the first one. Let me pick integration. That is the other one. And over here, let's get started with the basic idea. So there's nothing to copy. Just sit back, relax, grab a packet of chips or popcorn if you have, and some drink, and just sit back, relax, and watch. So lecture number one, that was the basic idea of differentiation. What is the basic idea? The basic idea is that differentiation is about the rate of change. How is y changing with respect to x? Y is equals to ax power n. This variable, this constant that is multiplying, that remains as it is. The variable gets differentiated. Power comes down, x remains as it is, power reduces by 1. And then rule number one, that is this thing. You can take a on the outside. My bad, I opened up integration. So let me just go over here. My bad. That was the differentiation part, but I opened the wrong PDF. So differentiation, different tangents can be drawn at this point. And when we use the O-level method, drawing a tangent, taking 2 points on the line, that is an estimate. When we do the calculation using differentiation, that is exact. Rate of change of y with respect to x, that is differentiation. So dy by dx at a particular point, that gives us gradient of tangent. And this dy by dx, that is known as gradient function, because as the name suggests, it gives us the gradient. And which gradient does it give? Tangent. We know from perpendicularity that if two lines are perpendicular to one another, the gradient multiplied to give you -1. So gradient of normal is negative reciprocal of gradient of tangent. That means if I draw a line over here, something like this, that is too thick of a line, that is tangent to that is normal to one of the tangents. So this is normal. And let's say I take this as the tangent. So they are perpendicular to one another. Equation of tangent, equation of normal. They can ask you about intersection of line and curve, simultaneous equation, rates of change. Y is changing with respect to x, x is changing with respect to t. In other words, y is changing with respect to t. This is also known as application of chain rule, stationary points, and all these things. So now from here, we start with rule number 1. Y is equals to x power n dy by dx. Power comes down, x remains as it is, power reduces by 1. Now over here, if there is a constant a over here, that constant plays no role in differentiation. Very simple. Some examples over here. Rule number 2, if the power is 1, therefore dy by dx is simply m. That can also be related to coordinate geometry. Y is equals to 2x, dy by dx is 2, gradient is 2. Rule number 3, if y is equals to a constant, derivative is 0 because y is equals to constant is a line parallel to x-axis, gradient is 0. Rule number 4, that is chain rule. Just have a look till I sip my tea. And over here, people, I won't be looking at the comments very much. I mean, they are nice comments and they are like teasing each other. But let me just focus on my teaching. Some other day, inshallah, we can have fun. So y is equals to something raised to power of n. Power comes down. Whatever's inside remains as it is. Power reduces by 1. Don't forget derivative of bracket. Dy by dx is first derivative. D square y over dx square, that is second derivative. When you differentiate, power comes down, bracket remains as it is, power reduces by 1 into derivative of bracket. There is no limitation as such. If something is downstairs, bring it upstairs and then differentiate. If there is a third, write it as a power of half. Sometimes first multiply, then differentiate. So now these are the small pointers that I'm giving. First multiply, then differentiate. This is the same. First multiply, but it has a lot of application of indices, and then differentiate. First divide, then differentiate. Gradient of tangent is dy by dx, negative reciprocal, equation of line, and so on. The line is a normal to the curve. So step 1, write it in the standard form. This gradient is gradient of normal. So gradient of tangent is +3. We are interested in finding the value of constant k. This line is normal to the curve. So therefore, we have dy by dx that is equals to 2x minus 5 equated to gradient of tangent. You find the value of x. At the point where the x coordinate is 4, gradient of tangent is 3. We can find equation of normal. We can find equation of curve. This is common point between the two. Plug it in over here, find the y coordinate. Now plug in y, plug in x, and what will you find? The value of k. Now over here, find the equation of tangent. Nothing special except the powers are in fraction. So 3 over 2 comes down, power reduces by 1, it becomes half. Half comes down, power reduces by 1, becomes negative half. And the rest is simplification. Now this one, the curve C has equation such and such. The curve C2 has equation such and such. The tangent to C1 at the point where x is equals to 3 is also tangent to C2. Now this was a 5-star level question, a very tough question, very conceptual question. Just have a good look at it. Find the value of k and the coordinates of p. So now this is y, this is dy by dx. When x is equals to 3, y is 4, that's the coordinate. And when x is 3, dy by dx is 2. So we have 3, we have 4, we have 2, we find the equation of the tangent. C2, y square is 4x plus k. Y is equals to 4x plus k square root dy by dx. That is this thing. That is the first thing. Method 1, line is tangent to the curve. This is the easy method. Just go with that. Just make it a single equation. Apply the concept of discriminant. B square minus 4ac is equal to 0. We find value of k, which is negative 5. And when the discriminant is 0, the quadratic formula reduces to this. So you find the value of x. So over here, that was the quadratic equation. The value of a is 4. The value of b is negative 12. Negative of negative 12 divided by 2a. That x comes out to be 3 over 2. Now we can plug in x. We can plug in k. We find the value of y. Y is plus minus 1. Now either y is positive 1, negative 1. How to decide? Find equation of tangent of C2. And equate it to equation of tangent of C1. That is method 2 that I have described over here. So now y is equals to 2x minus 2. This is gradient. That is x coordinates. Now plug x coordinates in equation of C2. And then you decide. One is giving us the variable is disappearing in one of them. What about y is equals to negative 1? When we plug this thing over here, the variable disappears. So this is useless. Got the idea? Let me just recap it for you once again. That was a tough question. We get y is plus minus 1. Either it's 3 over 2 comma 1 or 3 over 2 comma negative 1. Now how to decide? We would decide that when we have this equation of the tangent and we have this thing over here, y is equals to 1. Based upon that, we find the equation of the tangent. When we find equation of a tangent using negative 1, the variable disappears. So that value is invalid. So yes, this was a tough question. And just look at the mark scheme. Okay. Now, an examination tip. If such a question comes and your mind doesn't work, and that can happen, nothing special. Because sometimes things are very tough. So now, when such thing happens, leave that question and go back and go forward. So now, something over here that is last minute pointers, let's ignore it. Even life. Okay. And let me just put it forward. Okay. Now, the first thing is this thing. And then if you want, I'll share these pointers with you. Whenever I try to make a circle, it slips. So now, pointer number 1, that is skip any difficult part and come to it at the very, very end. So do not argue with that question. That is very necessary. So now the next one. So that is about differentiation. Let me now talk about rates of change. I gave this famous example. there is a circular patch of oil. With the passage of time, the radius of this increases, the circular patch. With this, the area also increases. So R is dependent upon T, A is dependent upon R, therefore A is dependent upon T. That's common sense. Now, in terms of differentiation, the first and the last variable, dA by dt, that is dA by dr into dr by dt. Dr by dt, centimeters per second, meters per minute, kilometers per hour, meters per day, something like that. dA by dr, that is obtained from the formula that relates the two. If it's about a circle, you would use the circle formula. And if it's about, let's say, a sphere, surface area, you would use the surface area formula. If it's about a volume, you would use the volume formula. Whatever formula is there, you would use that. dA by dt, if it's centimeter per second, this will be centimeter square per second. If it's units per second, it would be unit square per second. So very likely, this will be given by plugging in a value. This will be given, you can find this. Or this will be given, this will be given, you can find this. This one is a tough one in which this and this is given. You have to find this. You have to make it the subject. Let's say dA by dr comes out to be something, and then equate it to some value. I mean, dA by dr, let's say that's 2 pi r. And this value comes out. So equate, and then you find the value of r. So such a question will be seen very soon. Something like a basic question. Not a basic question. That is the one, that last thing I was talking about. The point Pxy is moving along the curve in such a way that the rate of change of y is constant. Find the values of x at the point at which the rate of change of x is equal to half the rate of change of y. Rate of change of x is equals to half the rate of change of y. Rate of change of x is this much. Therefore, rate of change of y is twice rate of change of x. So I have to flip the statement. If x is half of y, in other words, y is half of x, so dy by dt is 2 times dx by dt. Now, if I compare it with dy by dt is dy by dx into dx by dt, so what is dy by dx equals to? 2. That is dy by dx equated to 2. You get a disguised quadratic equation. So now we are studying differentiation, but disguise seeps in. And then you solve this equation, you get 2 values of m, and then you get 2 corresponding values of x. Similarly, if such a question comes, it's a cuboid, the dimensions are given. The surface area of the cuboid, it's a solid cuboid. If it doesn't say solid, that means assume it to be solid. And then that is 28x squared, that's the surface area. Volume is length into width into height. That is this much. First thing they're saying, show that S is equals to 7v raised to power of 2/3. A nice question. Again, indices. So let me take v. Let me raise to power of 2/3. Let me multiply it with 7. That should equal to surface area. So v is 8x cubed raised to power of 2/3. The 3 and the 3 cancels out. 8 square is 64. And my bad, 8 raised to power of, is it 2/3? This is 2/3. Volume raised to power of 2/3. So therefore, this thing is 8 raised to power of 2/3. And x raised to power of 2/3, 3 into 2/3. That is left with 2. And this 8 raised to power of 2/3, I have done it in 2 ways. So we are left with 4. So 7 into 4 is 28x squared. Then they are saying the volume of the cuboid is 1000. The surface area is increasing at this. Find the rate of increase of volume. So first of all, surface area is 7v raised to power of 2/3. The surface area is coming out to be 700. Surface area is 28x squared. X comes out to be 5. Volume, x comes out to be 5. So you can either achieve x from here or from here. So now, this was again a nice question. Area, that the surface area x and t, that's how they are related. Volume x and t, that's how they are related. So dA by dt is given, dA by dx is given. You find dx by dt. And that's over here. That's the working downstairs. And once you have found dx by dt, you can plug this 1 over 140 over here. And you plug in x is equals to 5 over here. So 24 into 5 square. That is dv by dx. And they are asking about find the rate of increase of volume. So now it's not over yet. It's done over here. So now it's shifted and this thing a little bit. So let me first copy this, cut it from here, and let me add a page because it was written upside down. So now let me adjust it. Similarly over here, let me adjust it over here. Okay, so this is 3 significant figure. So this 8x cube was over here and like this. So now that is the concept over here. Now let's read through it again. Surface area is 28x squared, ds by dx is 56x. Plug the value of x is equals to 5. So when we plug in x is equals to 5, ds by dx comes out to be 280. dx by dt is 1 over 140. That is obtained from here. So therefore, let me copy this thing. And that's how this thing is done. That is the first part. Then it further says that the volume is 8x cubed. Plug in x is equals to 5. Plug in x is equals to 5. So therefore, dv by dx is 600. That is the next thing. Then from here, let's pick this thing up. That is 1 over 140. That goes over here. That is 600, the blue one, that goes over here. And then you multiply it out and you get this answer, 30 over 7. You can leave the answer as fractions. You can leave the answer in significant figures. So now that brings us to the next thing, which is the next important pointer that people ask a lot. And yes, we cannot wait till the very last to write down all these pointers. So as soon as they pop in, we have to write. So now these are tips and tricks. That is pointer number 2. That is exact form. 3 things are there. By now, of course, you know it. Writing as a fraction, writing in terms of pi, writing in terms of square root. Significant figures. Work in 4SF. Final, that is 3SF. Decimal place, that is only for angle in degrees. Everything else is about significant figures. That is work in 2dp. And the word is at least. You can even work in 5SF. You can even work in 3dp. Therefore, the final answer is 1dp. So now, wherever, whenever possible, fractions are supreme, fractions are beautiful, fractions are exact, just work in fractions. Coming back to this, this thing is done. Now let me talk about stationary points. So stationary points, that means over here, the slope is 0. So let me draw a line like this. Let me draw a curve like this. So wherever there is the stationary point of any curve, the gradient is 0. So therefore, we would write dy by dx is equals to 0. That is the concept. You get the x coordinate of stationary point. To find the y coordinate, use the equation of the curve. For the nature, use the second derivative. Positive is minimum. Negative is maximum. 0, the proper terminology is point of inflection, but that's not part of the syllabus. So we simply say it's neither a max nor a min. The best example of A turning point, which is neither a max or a min, is that of y is equals to x cube. And that can also be that for y is equals to negative x cube. Something like this. A curve has this equation. Find the values of x at which the curve has a stationary point and determine the nature of each point, justifying your answer. That is based upon the second derivative. Y is equals to 8x, 2x minus 1 raised to power of negative 1, dy by dx, that is 8x becomes 8, negative 1 comes down, bracket remains as it is, power reduces by 1 into derivative of bracket. This step is good for further differentiation for the second derivative. This step is good for solving equation. It's good for the expression. So everything has its significance in life and in maths. Second derivative, this 8 becomes 0. This negative 2 multiplies with this negative 2. This bracket remains as it is. Power reduces by 1 multiplied by derivative of bracket. That becomes this. Dy by dx equals to 0. When such a scenario occurs, take square root, apply both the positive negative sign. You get two values of x, 1/4 and 3/4. Second derivative, when we plug in 1/4, we get negative. When we plug in 3/4, we get positive. One of them is a max, the other one is a min. Something to do with this thing. This is also a nice one. The curve has a stationary point at -1, 2, and 3, k. Find the values of the constant a, b, and k. So when x is -1, dy by dx is 0. When x is 3, dy by dx is 0. So now over here, that's the first equation, that's the second equation, solve it simultaneously. Let me look at something like this. A horizontal base of a solid prism is an equilateral triangle of side x. The sides of the prism are vertical. The height of the prism is h. Volume of the prism is this much. Express h in terms of x. The variable which disappears, that is earlier made the subject. And the total surface area of the prism is given by such and such. So now volume of prism, base area into height. First of all, what is the base area? So have I calculated the base area separately? Let me just double check. Yes, over here. So now over here, it's an equilateral triangle. I can either use half AB sine C. I can also find the height. So it's your choice. Area of triangle, half AB sine C, that is this thing. So this 2 and this 2 multiplies and give you 4. Base area into height, that's 2000, make h the subject. Area of prism, that's area of top, which is a triangle. Area of bottom, which is that triangle, plus 3 vertical walls. So that's the left wall, that's the right wall, and this one is the front wall. They all have the same dimension, that is x and h. So that is x and h multiplied by 3. Simplify, you get this answer. Now, don't be afraid of such a question. When you differentiate, this is a constant, this is a constant. Focus should be on the variable. That's the variable, that's the variable. Just have a good look. So now this variable 2 raised to power of x raised to power of 2 becomes 2x. X raised to power of -1, that is -1, x raised to power of -2. That is written like this. Multiply and equate it to 0. All the working that you need to do with algebra, you're all set. So I think we spent around 30 minutes on differentiation, maybe some basic talk, and then 25 minutes. So let's remove this. Let's talk about integration. Y is equals to ax power n. That is differentiation on the left. Integration, any constant that is multiplying, that plays no role in differentiation, or for that matter, integration. You can take it outside. Increase the power by 1, divide by the new power plus a constant of integration, valid for all the powers except n is equals to -1. Then we talk about the chain rule of integration. Ax plus b raised to power of n. Increase the power by 1, divide by the new power, divide by the coefficient of x. Now there are two limitations of this chain rule. And what is the limitation? So rule number 2 is chain rule of integration. That is, n can be any power but -1, and this expression has to be linear. That is why coefficient of x is the same thing as derivative of bracket. Some examples. Lot of indices, that's always there. If there is a constant, when you integrate, you get mx, because when you differentiate mx, you get m. Multiply, then integrate. So this one I have done multiplication, but I think I forgot to integrate it. So let me just do the correction over here. That's over here. So therefore, this becomes x cubed over 3, 5x squared over 2 plus 6x plus c. Now, what is the lesson that I learned from here? The third lesson that I just learned right in front of you. No scripted thing. It's this real thing that I slip. So now I always try to make a circle. The third thing that we learned is that always double check you're working. No matter how smart you are, it's always a good idea to check. Because the paper is for 1 hour, 50 minutes, 110 minutes. Yes, it's tiring. So you need to refresh up a lot. So you need a candy bar, a chocolate, something like that to refresh you up. The sugar will go up. And then always read carefully. And then reread the question. Reread the question after you are done to check whether you have supplied the necessary answers. Because it's just a game of supply and demand. So if this thing is done to the level of accuracy, showing all the working, so that is a must. And one other thing that you are seeing right now, that is this thing, that whatever working that I'm doing, and of course, all the students who are studying from me on a regular basis, they know this. That is show all steps. I never compromise on this. I never compromise on neatness. I never compromise on the logical steps. I assume nothing. So do not assume anything. That means tell everything to the examiner. So show all steps. That is again what I mean by do not assume anything, and then read carefully. Very necessary. Is it asking about exact form? Is it asking about decimals? Is it quite on this matter? Then it's your choice. So 4 tips till now. Let's move ahead and come back to this. So now sometimes you have to multiply and integrate. You have to divide and integrate, take care of all the steps, show all the steps. This is application of chain rule, increase the power by 1, divide by the new power, divide by coefficient of x, simplify. Power of half, yes, it will work. Something like power 4 in the denominator, take it up. Sometimes you have to square it. So 4 square becomes 16. This is 3x plus 1 whole square. Never ever open the bracket in the denominator because you cannot integrate it. The rules are for numerator. Chain rule is not applicable because this is not linear. So you have to open up the bracket. This is not linear. Open up the bracket and then integrate. Constant of integration. Yes, we write a constant of integration because we don't know whether there was a constant earlier on or not. And we evaluate it later. Gradient function to equation of curve. That's how you do it. Gradient function is given. It passes through a point. So dy by dx disappears. Y appears. Integration and dx appears. Integrate it individually. Integrate it as a bracket with the power of 1. Evaluate c by plugging in x and y. Something like this. The equation of a curve is this: dy by dx is 12 over 2x plus 1 whole square. The point 1 comma 1 lies on the curve. Find the coordinates of the point at which the curve intersects the x-axis. First thing first, take it up. Then take 12 on the outside. Put the integral, put the dx. Once you start integrating it, the integral disappears, dx disappears. Yes, c will appear. First simplify, then plug in the value. A very, very important reminder. First simplify. Whether you are doing an area question, whether you are doing a volume question, whether you're doing a simple gradient function to equation of curve question, first simplify and then insert values. Those values can be about x and y. It can be about the limits and so on. Evaluate the constant of integration and don't leave over here. The examiner is asking about finding equation of the curve. And then not just equation of the curve, find the coordinates of the point at which the curve intersects the x-axis. So you cannot move on unless and until you have the equation of the curve. So curve intersect x-axis, therefore y coordinate is 0, and then you can just have a look over here, and then you write the final answer as a coordinate. That thing is done. Uh, Something in which there are two unknowns, because you can see a constant in the beginning. So you can right away see that there is a constant which is already there. And the second constant will be what? That will be the constant of integration. So that is why two conditions are needed. So dy by dx is like f prime x. Integrate each term. Of course, you cannot use chain rule. Plug in 0 to one equation, plug in 3 minus 1 other equation, solve it simultaneously. You find the value of c and k. Something like this. Just have a good look at the question. And let me just change my seat. So now this question is about differentiation, and maybe they can be asking about integration also. So let me just get water also. Now it says a curve is such that dy by dx is this much, where a is a positive constant. The point A lies on the curve. Find in terms of a the equation of the tangent to the curve at A, simplifying your answer. So now over here, sometimes these questions, they cause you a little bit of trouble, because it's not just numbers, it's some like constants and cubing and squaring and square rooting, and all these are tough issues of life. So now over here, we have dy by dx is this much. Now, first thing that you need to check, is it written in the proper format for integration? Yes, it is. So this one is taking it up. The first thing, equation of tangent. Okay, the first thing is the equation of the tangent. So this is not integration. That is the second part. So now a square is plugged in over here. A square is plugged in over here. A square is plugged in over here. So now just double check. Square root of a square is a. This a and this will cancel. This is a, this is a, another a square. So 2 over a square plus 1 over a square, that's 3 over a square. Gradient of tangent is dy by dx. That is this thing. That's the point. That is the equation. Are they asking us to simplify? Simplifying your answer? Yes. Then it means make y the subject. So they haven't said as such, but you cannot leave it as it is unless they were saying just the equation. So just equation. So then this is good. If they ask this, that is simplifying your answer. So simplifying your answer means do your level best, simplify as much as possible. That's the first part. The second part, the equation of the curve. Just have a good look. Just look at the complexity of this question. Yes, you need to know your indices. So without indices, you are nowhere. So you need that particular question. That is y is equals to 2 over a x raised to power of negative half. So now why is it causing trouble? That is x raised to power of negative half plus 1. So just focus on the highlighting that I'm doing. Negative half plus 1, negative half plus 1. Over here, negative 3 over 2 plus 1, negative 3 over 2 plus 1. And then division by half is multiplication by 2. So division by half is multiplication by 2. And division by negative half is multiplication by negative 2 over 1. And then simplify as much as possible. You have the C. And do we have the condition? We have the coordinates, the same one, a square comma 3. So now a square comma 3 that you plug in. So therefore, wherever there is x, there is a square. So there is a square over here, there is a square over here. And let me just do one correction that the square root is applicable on the whole thing. So that is like this. And wherever there is y, there is a 3 over here. So there is 3 over here. And then we evaluate and we find c, and c comes out to be 1. And that is how the equation of the curve is written. So now that was a good question. And now the last part of this, it is now given that b is 16, 8 also lies on the curve. Find the value of a. And using this value, find the distance AB. So now we have the equation of the curve. We plug in x and y. So now the orange one, that is the y coordinate. And the green one, that is the x coordinate over here. And then you are able to find the value. And now it's a disguise, no, just a normal quadratic equation. A is negative, A is positive, and that is the answer. And then the distance formula. Now let's talk about area under graph. So now someone, this thing, people have some troubles in it. So now area under graph, trouble, not troubles. So area under graph, area with x-axis, just integrate, plug in the limits, you get the answer. That is a simple area. Simple area with y-axis, integrate and plug in the limits. But there has to be some difference between the two. So what is the difference? The difference is this. When we are finding area with respect to x-axis, so your equation is in terms of x. You write a dx over there, and then your limits are on the x-axis. Limits on x-axis, equation in terms of x, and you find area under the graph with x-axis, and there is dx. Everything flips over here. So when we are calculating area with respect to y-axis, so now instead of dx, we have dy. Instead of fx, we have fy. That means equation is in terms of y. And instead of the limits on the x-axis, the limits are on the y-axis. So in area, you have this liberty of thinking whether you want to differentiate, integrate with respect to x, with respect to y. In area, you have this. And you just evaluate this answer. So now when you plug in the limits, c disappears. You plug in the upper limit, you plug in the lower limit. Yes, a very important rule. That is, if you integrate a function between the limits a and b, that is the same thing as integrating the same function with a minus on the outside and the limits are reversed. In other words, if I have this thing over here, minus sign, and the limits are a at the top and b at the bottom, if I want to remove the negative sign, make it positive, then I can change the limits. So this comes in handy. Not necessary, but comes in handy. If it's a straight line, we can either talk about a triangle, we can talk about a square, we can talk about a rectangle, we can talk about a trapezium. So all those areas can be found out using this thing. Curve, you have to use integration. Integrate, plug in the limits, evaluate. So this is y is equals to 2x, this is y is equals to x squared. So what if I draw both on the same grid and there is some area in between? So the top one will have more area, the bottom one will have lesser area. So area in between, that is the difference between the two areas. They were already calculated before. So I use the same result for this one. So this is between. Area below the x-axis, just the normal thing, but it will come out to be negative. That shows that you have done it correctly. Simply discard the negative sign at the very end. Area under two separate graphs. This is area under the line. This is area under the curve. Evaluate it separately. This is underline, this is under curve. If they ask for the total, add it up. If they ask for the ratio, divide. Something about improper integral. Y is equals to 1 over x square. You have to write this thing as x raised to power of negative 2. So area under the graph between the limits a and 1. I have not mentioned what a is at the moment. That is coming out to be 1 over a minus 1. And area under the graph between 1 and b in terms of a and b, that is coming out to be 1 over 1 minus 1 over b. Now, if a is so small that it's almost 0, any number divided by 0 is undefined, it's an infinite area. On the other hand, if b is so big that it's almost infinity, 1 over infinity is 0, this is a finite area. So it's an irony. That is, there is a value of 0, but this area is infinite. And b is infinite, but the area is finite. This is called improper integral. Just have to remember this thing. So now let me write one other thing over here. That is step number 5. So let me choose this color. And that is tip number 5. That is 0 divided by any number is 0. Any number divided by 0 is undefined. And any number divided by undefined, that is 0. So these come in handy very much. So now coming back to this, the integration. Now let's talk about volume of revolution. And I said earlier that we would take around like 40 minutes, but no, it's coming up to an hour. So 2 topics about an hour. Don't worry, we have the whole night. You don't have an AM people. You don't have an AM paper. You have a PM paper. So this will be the last thing that you will do today. And you won't be studying anything extra in the morning. Just this much is enough. You will have sweet dreams. Okay. So now volume of revolution. Volume about x-axis. Now something extra. Of course, that was area. This is volume, something extra without any logic. Just the crux of the matter. There should be a pi. The function should first be squared, then integrated, then the limits should be plugged in. Don't forget to multiply by pi. First square, then integrate, plug in the limits. Don't forget to multiply by pi. This is with respect to x-axis, and there is no choice. If they say about the x-axis, it better means about the x-axis. Volume around the y-axis, the limits are on the y-axis. The function should be in terms of y. In other words, x is the subject. When the function is in terms of x, y is the subject. Dx is replaced with dy, limits on y-axis. Y is the same process. Volume under the line. Yes, it can become it becomes a cylinder. My bad, it becomes a cone. A horizontal line becomes a cylinder. But we won't go into that much detail. We would simply follow integration because people mess that up badly. So now 0 to 2, this is 2x whole square. Just go very, very slowly. Some people are in a hurry to go nowhere. They want to square and integrate in one shot. That's their choice. That's their grade. What you call in Urdu, mera grade, meri marzi. But don't do that. I would prefer that you do follow the steps. There is no hurry. 110 minutes is a lot of time. If you follow my instructions wisely, you can easily finish in like 90 minutes, 90 to 95 minutes. So 4x square, and then integrate 4x cube over 3. Take the 4, take the 3 outside. Pi was already waiting for the friends. So now x cube integration is already done. Plug in upper limit, plug in lower limit. That's the answer. This is cubic units. That is cubic. That was square units. Y is equals to x square. So x square becomes square, x4, integrate, plug in the limits. Join the two forces. volume of revolution between two graphs. They can ask about, they can use the term volume of revolution. They can use the term that is what you call volume of solid of revolution. Okay. So now different kind of names are used as long as its volume doesn't make a difference. So now over here, what needs to be done? That is that what you will do is that first find the volume produced by this line. That was already done. Then find the volume produced by the other thing, which is what you call curve. And we are interested in volume in between. So just find the volume in between. That is the thing and nothing more. Now I'm looking for something that I cannot see over here, the screen recording thing. Okay. So now over here, similarly, x square minus x, now you have to square it. Chain rule is not applicable. You get three terms, you plug in the limits, volume will always come out to be positive. Remember, the area earlier was coming out to be negative, but volume is coming out to be positive. Volume produced by two separate graphs. This one is under the line. This one is under the curve, the region. X becomes squared, plug in the limits. X raised to power of negative 2 becomes squared, x raised to power of negative 4. Two separate volumes. If they ask for the total, then evaluate. Now, a question like this. The diagram shows part of the curve with this equation and the line OA, where A is the maximum point on the curve. A is the maximum point. The x coordinate of A is small a. Curve has a minimum point at B, which is B comma 0. Not only it's a minimum point, it's also where the curve is tangent to x-axis. A and B are positive constants. Show that B is equals to 3a. So y is this much. Dy by dx is this thing. Dy by dx is equals to 0. When x is a, this is what we are getting. When x is b, y is 0, dy by dx is 0. So that was extra. As such, nothing was used over here. Now we have to what you call middle term factorization. So this is like 3a squared. This is like b squared. So this is 3a squared b squared. Break this up. That is minus 3ab minus ab. Middle term factorization, a is equals to b, reject. How is that possible? How can we have a and b the same? Impossible. And b is equals to 3a. That is how you prove it. Okay, so that was a nice question. Then let's talk about something like this. This is an equation. They're asking for area. So just want to focus on one thing. First of all, this was the normal. That is differentiate, find the dy by dx, plug in the value of x is equals to 3. Dy by dx is coming out to be 5 over 6. So gradient of tangent is 5 over 6 and gradient of normal, my bad. This is the curve. That's the gradient of tangent. That is 5 over 6 and gradient of normal is negative 6 over 5. So just to give you that reference over here, that is the gradient of tangent. Let me make it thinner. That is tangent. And this green one is the normal. So now we can find the equation of the normal, or we know that it cuts the x-axis at b comma 0. So we can just use the gradient formula. We find the value of b, which is 4. So now the base is 1 because this was 3. This x coordinate was 3. This x coordinate was 4. The difference is 1 unit. The height is 6 over 5. That's the area under the line. Area under the curve, that is not from 0 because it's not touching the x-axis. This is 5 over 2. This is 3. So it's between the limits 5 over 2 and 3. That is basic. That is basic. That is chain rule. So yes, you can get a combination like this also. That is where you have to be very, very vigilant. And this one is area under the curve and between two things. So now this one is a rectangle. For area, you can use these area of 2D figures. That is rectangle 15 into 5. Area under the curve between 1 and 16, so that you can find out. This one, the area is enclosed by the y-axis and the line y is equals to 5 rotated 360 degrees. I think the working is over here. Now, first of all, I have a habit of making y the subject. I can simply make x square as y minus 1, and there was no need of squaring. But I might forget or I might get into a bad habit. So therefore, let me write x is equals to y minus 1. So y minus 1 square root, the whole thing square. That's y minus 1 raised to power of 1. Increase the power by 1, divide by the new power, divide by the coefficient of x. So even if it's something as obvious as the coefficient is 1, still I'll write it. So I'm not in a mood to take any chances. Plug in the limits, you get this answer. And let me see if there is any other question that I can do. Something like this. The last question of volume. So now find the volume obtained. It's about the x-axis. So that's the curve. Again, it's y square. Again, I have made y the subject, x minus 2 square root, then square it, write it once. Chain rule, plug in the limits. That's volume under the curve. And the line is y is equals to 1. It's a flat line, gradient 0. So 1 after squaring becomes 1. Integrate, plug in the limits. This is 4 pi. This is 2 pi. The difference is 2 pi. So now, right now, at this stage, we are done with the first part of our stream. That is differentiation, integration, and that took exactly 1 hour. So let's take a 7-minute break, get yourself refreshed up, and then we will continue with the next part of the journey. So let me just put that thing over here. The stream will continue, something like that. Okay. So I think that's good enough. And see you very soon. चले जी, get ready. Bismillah करते हैं. So now we are talking about some other things. So let me just move. Integration is done. Now let's talk a little bit about quadratics. Let's talk a little bit about functions. I think function is already over here. Yeah. So now the thing is gone. Hold for a second. Okay. So now people, when we talk about quadratics, and I hope you can hear my voice, and let me just double check it myself. Okay. So now when we talk about quadratics, there are lots of things in quadratics. 1006, and we have started. There is about simultaneous equation. There is disguised quadratic. There is completing square method. There is factorized form. There is sketches, discriminant, and so on. Factorized form, taking common is factorization. A square minus b square, a plus b, a minus b, that is factorization. Middle term factorization, yes, of course we know it's factorization. Factorization by grouping, 4 terms are given, make groups of 2, that is factorization. Basic x square sketch, minimum point at 0, 0. Coefficient of x square is positive, happy face. Coefficient of x square is negative, sad face. Factorized form, we get the roots, focus on the coefficient of x square. So based upon roots, based upon the shape, we sketch it. This is sketching. Between the roots, there is x coordinate of turning point, a vertical line through it. That is the line of symmetry. So that is the basic idea of this thing. What else is there? That is the same thing written over here. X square minus 4x, again factorize. 0 and 4, x is equals to 2. That's the x coordinate of turning point. Plug in the equation, you find the y coordinate of turning point. X is equals to 2. That is the equation of the line of symmetry. Something like this. Coefficient of x square is negative. It's upside down. Solving quadratic inequality, drawing a sketch is a must based on factorized form. You draw a sketch. If it says solve the inequality y greater than 0, that is the region above the y-axis. 2 separate regions, 2 separate answer. Extreme right, extreme left. If it says y is less than 0, one single region below the x-axis, one single region, one single answer. If x lies between 0 and 4, y value is negative. If x is greater than 4, y value is positive. If x is lesser than 0, y value is positive. That's the basic idea. If it's greater than or equal, then this equality occurs. Lesser than or equal, then this inequality occurs. Something like completing square form. The process, you have to define the process. Make sure coefficient of x square is 1. If not, take that coefficient common throughout. First 2 term, push it to the side. Constant, push it to the extreme right. First add, then subtract. Square of half the coefficient of x. Rewrite the first 3 terms as a perfect square. Simplify the rest. That is the gold standard. We will always compare with this. A x minus h whole square plus k. We won't compare it with anything else. Now over here, the process x square 4x plus bracket square minus bracket square plus 12. That is how you do it. Take 2 common out. Simplify on the inside, x square minus 4x plus bracket square minus bracket square. What goes inside the bracket? Half the coefficient of x. Rewrite the first 3 terms as a perfect square. Simplify the rest. Your choice. First simplify, then multiply. First multiply, then simplify. Then doesn't make a difference. Now, sometimes life is full of fractions. So maybe you get a fraction like this. If the middle sign is negative, then this thing is negative. It's a minus b whole square. If this sign is positive, it's a plus b whole square. So life is full of fractions. Use fractions wisely. Okay, so now how do we use the completed square form? We use it, the a is still the shape of the graph. And then h comma k, that's the coordinate of the turning point, also known as vertex, also known as stationary point. X is equals to h. That's a line of symmetry, which we have seen in the factorized form also. That is how you will do the comparing coefficient and you will sketch it. The vertical line of symmetry, that's not needed as such unless they ask for it. So it's just the basic turning point and the shape. Again, comparing coefficient, there is a -1 on the outside. It's upside down. Again, h comma k. Something like this. If it's written in the reverse order, first write in the proper order and then compare coefficient. Something like the discriminant concept, the general form of quadratic equation, the thing inside the square root, that's called the discriminant. If the discriminant is positive, you get two answers. That means two solution of equation, two x-intercept, two roots. If the discriminant is 0, one answer, one solution. If the discriminant is negative, no answer, no solution. If it's cutting at 2 points, we say the roots are real because you can see it for yourself. The roots are distinct because they are different. If it's b squared minus 4ac is equal to 0, you get only one answer. Line is tangent to the curve. Curve is tangent to x-axis. B squared minus 4ac less than 0, imaginary roots. As opposed to real, it's imaginary. So greater than 0, equal to 0, greater than or equal to 0, that is real roots. Now, this thing, very important, asked very rarely, but yes, it's part of the syllabus. That is, if b squared minus 4ac is less than 0, imaginary roots, the graph could either lie above the x-axis or below the x-axis. If it's above the x-axis, coefficient of x squared is positive and discriminant is negative. If it lies below the x-axis, discriminant is definitely negative and coefficient of x squared is also negative. A line meets the curve at 2 points, make a single equation, discriminant greater than 0. Line is tangent to the curve, discriminant equals to 0. Line does not meet the curve, discriminant is negative. Line meets the curve, maybe at 2 points, maybe at 1 point, discriminant is greater than or equal to 0. A question like this, express this thing in this form. Hence or otherwise, find the set of values for which this thing is greater than 9. I'll use the otherwise option, that is the quadratic inequality option. Something like this thing. This is kind of difficult, just ignore it. Find the value of constant k for which the line is tangent to the curve. This is curve, this is line, just make a single equation. So just make a single equation, simplify, lots of algebra, and then b squared minus 4ac is equal to 0. So when they ask for value or values, it means it's an equation. When they ask for set of values, it's a inequality. So let me write over here. That is over here. That is step number, what you call, 6. That is 5. So now it's 6. That tip number 6 is, if they are asking, hold for a second, black marker, in quadratics, if they're asking for value or values, that means it's an equation. If they ask for set of values, that means it's an inequality. Got the idea? And a quadratic inequality sketch is a must. So the answer should be based on sketch. It's not calculation based. Coming back to this. Something like, if they ask you, find the common point, it's just a continuation of that thing. Find the common point between the line and the curve, or find the point at which line is tangent to the curve. So now we got value k is equals to -3. We plug it in over here and we get x is equals to 2. Plug in the line equation, we get the y coordinate. Alternative way, a is 1, b is -4. When real and equal roots, b squared minus 4ac equals to 0. The quadratic formula, this thing disappears. X is minus b over 2a. You also get the same thing this way. Y coordinates, use the curve equation, use the line equation, whichever one is simpler. Something like more about sketching, and that will be used in functions also. That is for quadratic equation. Y is equals to x square, happy face, negative x square, sad face, completed square form, factorized form, general form. We can use it all for sketching. Now a bit of translation and all these things. Y is equals to x square plus 1. So the original y is equals to x square is shifted up 1 unit. So translation vector is 0, 1. Y is equals to x square minus 1. It's shifted 1 unit down. Actually, x square minus 2. By mistake, it's written 1. So this is minus 2. Therefore, it is shifted 2 units down. Y is equals to negative x square plus 2. So negative x square was passing through origin. We are shifting it up. Negative x square plus 1, that is shifted up. Stretch parallel to y-axis. 2x square, it becomes steeper towards y-axis. Half x square, it becomes flatter towards x-axis. If k is greater than 1, more steeper towards x-axis, towards y-axis. If k lies between 0 and 1, more flatter towards x-axis. Reflection. Y is equals to x square. If you put a negative sign on the outside, it's reflection in x-axis. Y is equals to minus 2x square. So basically, it's a combination of two. So basically, draw 2x square and then shift it down and then flip it down. Or draw y is equals to x square, draw y is equals to negative x square, and then steepen it. So over here, as we will soon see, the order does not make a difference. Y is equals to minus 1/3 x square. That can also be drawn. Y is equals to x square minus x square minus 2x square. Y is equals to x square minus x square minus 1/3 x square. I have changed the order. First reflect, then stretch. It can also be first stretch, then reflect. Okay. Horizontal translation. Y is equals to x square, y is equals to x minus 1 whole, x plus 1 whole square. What do you observe? You observe that because of the plus 1, if I compare it with the completing square method, the turning point has shifted 1 unit to the left. Got the idea? And then y is equals to x square, y is equals to x minus 1 whole square. Compare it with the completed square form. Now the turning point is 1, 0. So that negative is actually making it move to the right. So it's the opposite rule. Y is equals to 2x square plus 1, stretch along y-axis, scale factor 2, then translate it parallel to y-axis, translation vector 0, 1. We will soon see the order in which transformations are applied. So after quadratics, I'll directly first move to that thing, and then we will talk about the domain, range, and all those things later on. So now this thing is there, and that will be the most important part of today's stream. Let's look over here. Y is equals to 1 minus 3x square. That can be written as negative 3x square plus 1. So basically, first stretch with a 3 scale factor along y-axis, then reflection in x-axis, then translation parallel to y-axis with a vector 0, 1. So this is y is equals to x square. This is steeper. Y is equals to 3x square. This is negative 3x square. This is negative 3x square plus 1. So that is a beautiful translation of this thing. So now over here, simultaneous, we know disguised quadratic equations we have seen. So let's move this. And now let me first talk about transformation. So everyone come closer, because now the real stuff is starting. So now, first of all, let me also write in the group that is this thing. Now over here, this thing, that is functions and transformation. So now there are some people I know that you might be stressed out, but just focus on the live stream. I mean, you people are writing so much in the comments. I mean, you have all the time in the world. I can understand that. And I cannot leak a paper the way that I'm teaching. If you follow that, inshallah ta'ala, it will be all good. So it's my 5th time appearing for P1 Maths. I mean, come on, people. क्या हो गया? अच्छा जी, चले जी आगे बढ़ते हैं, बिस्मिल्लाह करते हैं. So now there is a vertical transformation, that is reflection in x-axis. That is a vertical transformation. Okay. And what else is there? There is translation parallel to y-axis and fx plus k. So now over here, be very careful. Let's go easy on it. Plus k means translation vector is 0k because this is for y. So plus k is giving me plus k. Fx minus k, minus is giving me minus. Plus k means it moves up. Minus k means it moves down. So no doubt about that. Along y-axis, it's all beautiful. It's all good. It turns a bit ugly when we talk about translation parallel to x-axis. First of all, minus h is written as positive. It has the opposite effect. So just let me write over here, opposite effect. So when we write in the column vector, that will be the reality. So positive h means right. And plus h, it means a negative. So that means a left. And let me rewrite this thing again. So therefore, over here, let me choose a blue marker. And this is translation vector, and this is plus h and 0. So now over here, this negative is giving me positive, opposite effect. Positive is giving me negative. Whatever is written in the column vector, that is exactly happening. So plus h means right, negative h means left. Now let's talk about over here, stretch parallel to y-axis. So parallel or along, both words are perfectly fine. So now over here, when we say it's parallel to y-axis along, parallel to x-axis along, so now over here, there is a constant on the outside. This is on the outside. So scale factor is that outside number, constant. And over here, x remains as it is, y coordinate is multiplied by a. So y coordinate is multiplied by scale factor. Let's not write a, let's write scale factor. Over here, stretch along x-axis f of ax. Scale factor is 1 over a. This time, the x coordinate is multiplied by scale factor. So it's always the scale factor multiplying. X coordinate is multiplying by scale factor. That is the thing. So now once this is all good, all clear, let's move ahead. Now comes the idea. When one horizontal and one vertical transformations are combined, the order in which they are applied does not affect the outcome. That means if I write vertical horizontal, that is the same thing as horizontal vertical. For example, if I say let's reflect in x-axis, then reflect in y-axis. That's the same thing as first reflect in y-axis, then reflect in x-axis. Translation parallel to y-axis. Translation parallel to x-axis. For example, let's move up and let's move to the right. Doesn't make a difference. First move to the right, then move up. Stretch along y-axis, stretch along x-axis. So stretch along y-axis and then stretch along x-axis. Or stretch along y-axis and then move to the right. Stretch along x-axis and then move up. Stretch, reflect in x-axis and then translate to the right. So the order does not make a difference. Now, the next thing, the important one, that is vertical transformations. Vertical transformation follow the normal order. That is the mathematical operation that we use, BOD, MAS, bracket of division, multiplication, addition, subtraction. It follows the normal order. And over here, when we talk about horizontal transformation, they follow opposite to the normal order of operations that is used in arithmetic. Now, first, let me show you this, and then I have carefully jotted down some examples which will further enhance the idea. So now it says combining two vertical transformations. So fx is being transformed to a fx plus k. Now, first A is multiplying with fx and then k. So stretch vertically, scale factor A, multiply function by A, then translate 0k. That means add k to the function. It's moving up by k units. If k is positive, it's moving up. That is the normal thing. Now let's get started with this idea. And I would like you to first think about all these examples. First, the first three examples. Just focus on that. And then I'll move one up and so on. Let's focus on the first three, do brainstorming, and then I'll explain the solution. So now over here, brainstorm this thing. And the first three parts, that is A, that is B, that is C only for right now, because that's the one that you're seeing. Okay. I'm doing examples of transformation, so don't worry. Everything that we talked about, that will be done with examples. That's the whole purpose of the examples. So let me write over here, focus on examples, the one that I'm doing right now. Now it says gx is 3fx. What is happening? Simple transformation, that is, this is stretch parallel to y-axis, scale factor 3. Gx is fx plus 2. That means this is translation parallel to y-axis, and the scale factor is 0 and 2, the translation vector. Now this is a combination of a and b, gx 3fx plus 2. First stretch parallel to y-axis, then translate it 2 units up. So now let me go to the next page. That is over here. I have written it down already. Take a screenshot if you want to. Stretch parallel to y-axis, scale factor 3. Translation parallel to y-axis, translation vector this. 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this. So that's the standard. 2 marks for describing each transformation. Sometimes the examiner is short of marks. So maybe sometimes they give you 3 marks, but the rule is 2 marks for each transformation. The name and the scale factor. The name and the translation vector. So now it's a combination of these. That's the normal order. First stretch parallel to y-axis. That is this thing, and then translate it up. So let's go back up. The first three are done. Now let's focus on these three. Let's first focus on these two. Gx is equals to 3fx, that's my bad, that is D and E. This is minus 3fx plus 2. Now, either you can say that this is stretched parallel to y-axis with a scale factor of 3, and then a minus that is reflection in x-axis. Or you can also say it's a stretch factor of negative 3. So both are valid, and then plus 2. What about gx? Negative of this whole thing. So basically, this is this one, 3fx plus 2. This is part C. After you have done part C, whatever you have done, then reflect it in x-axis. What about gx? This is minus 3 of fx plus 2. So now this is minus 3fx plus 6. So you can also write it like this. If you open up the bracket, that is minus 3fx plus 6. So now over here, what we can do is that let's first transform it with a scale factor of negative 3, then translate it up by 6 units. Or if you have drawn fx plus 2, then stretch it after the translation, stretch the whole thing. So now over here, this one, almost same except stretch factor is negative 3, or stretch, then reflect in x-axis, then translate. Reflect C in x-axis. So C is this thing, 3fx plus 2. So minus on the outside, reflect part C in x-axis. Alternatively, expand. So just expand the whole thing, and then you get this thing. Okay, this is not alternative. This is just expand. So expansion will do better. Now we are talking about horizontal transformation. Now consider the graph of y is equals to fx is transformed to the graph of y is equals to bx plus c. Now what is your gut feeling? Your gut feeling is first take care of this, then take care of this. That is the normal order. But just like the normal way and the Mentos way. So the Mentos way is this thing. First take care of plus C and then take care of this. So let's look over here. Translate minus C0, whatever is the value of C, it would be the opposite, negative sign on the outside, replace X with X plus C. And then stretch horizontally with a scale factor of 1 over B. Remember, whatever is the coefficient of X, the scale factor is the reciprocal. So now if I write it again over here, y is equals to f of ax, the scale factor is 1 over a. Now let's do some examples and then we can do some past paper questions also. So now gx, that is f of 2x. So now f of 2x, what is happening? That is, the scale factor is 1 over a and this is stretched parallel to x-axis. So if I draw this line over here, that means parallel to x-axis, but in your exam, you have to write the whole thing. So there are no shortcuts. Gx is f of x minus 5. So minus 5 means translation vector is 5, 0, opposite effect, and this is translation parallel to x-axis. So G, H, and I. Now let's combine this and this. So f of 2x minus 5. Now first this will happen, then this will happen. Got the idea? Let's look at the result. First, stretch parallel to x-axis, scale factor half, reciprocal of the coefficient of x. Translation parallel to x-axis, that is a translation vector 5, 0. Gx f of 2x minus 5, opposite order. First translate with this vector, then stretch along x-axis, scale factor 1 over 2. Now let's just continue from this thing. F of negative 3x plus 4. Again, the opposite order. First, take care of this. First, translate parallel to x-axis. Since this is positive, negative 4, 0. Then stretch parallel to x-axis, scale factor minus 1/3. The coefficient of negative 3 is minus 1/3. Or if you want, you can combine it as, you can write it as two things. First, reflect in y-axis because of the negative sign. F of negative x, that is reflection in y-axis. Then stretch parallel to x-axis. Now over here, f of negative 3 of x plus 4. Now what it feels is that first stretch. Now first you feel that let's focus on this and then focus on this, because first, no, first focus on the bracket. That is your gut feeling, correct? That is the normal order. And then take care of this. So now it's the opposite. First do this. That is first stretch with a scale factor of negative 3 and then translate parallel to x-axis with a scale factor of this thing. So now this is one, both are horizontal transformation. Okay. And this is not minus 3. This is minus 1/3. Let me write this one over here. Now the same thing, I can do it easier by expanding minus 3x plus 12. Now this is easier. First take care of the translation, minus 12, 0. Then change, stretch it parallel to x-axis with a scale factor of minus 1/3. So I hope I have done enough practice of this thing. Now that was my first focus was, and let me pick few random questions from here. Something like this thing. Let me just first copy this. Let me do few problems. Now it says in the diagram, y is equals to fx is shown with solid lines. And the graph shown with broken lines is the transformation. So sometimes they write fx, sometimes they write gx, and so on. Describe fully two single transformation that have been combined to give the resulting transformation. So now it feels like some kind of translation is done. It feels like some kind of stretch has been done. So now whatever you feel like, I mean, you have to double check the result. That is the main thing. So now over here, what I can do is that, first of all, look at these 2 points. Look at the horizontal distance. Has it changed? Yes or no? No, it has not changed. That means there is no stretch along x-axis. That is the first thing. The second thing, what about the vertical height between this and this? It was 1 unit. Now the vertical height is 1, 2, 3 units. Yes, there is stretch parallel to y-axis. So now there might be some horizontal translation. There might be some vertical translation. I'm not sure. So now order won't make a difference. Let's take care of stretch first. So stretch parallel to y-axis, scale factor is 3. That means this point 2 comma 2, the y coordinate is multiplied by 3, that becomes 2 comma 6. So this is 2 comma 2, this becomes 2 comma 6. Now this point 2 comma 6 is 1, 2, 3, 4 units to the right. So there is a translation of 4, 0. Describe fully the two single transformations that have been combined. State y in terms of f and x and h. So one vertical, one horizontal, one horizontal, one vertical order does not make a difference. So I have replaced x with x minus 4 because it was moving 4 units to the right. So the translation vector was 4, 0. And then there was the stretch. So maybe if I move first 4 units to the right, 1, 2, 3, 4, this would be a 6 comma 2, and then we can draw this thing. So this is perfectly fine. Now let me choose some other questions, sometimes in which the wordings are used. The graph of y is equals to fx is transformed to the graph of y is equals to 2fx minus 1. Describe fully the two single transformations which have been combined to give the resulting transformation. So x minus 1, that shows that it's a translation parallel to x-axis. Minus 1 means positive 1, 0, translation vector. And this 2 on the outside, that is a stretch parallel to y-axis. The curve is reflected in y-axis and then stretched by a scale factor of 1 over 3 in the x direction. Write down the equation of the transform curve. So now over here, first thing first, they have already given us the order. So now reflection in y-axis. Replace x with negative x. Replace x with negative x. Sine of negative 2x, and this minus 5 minus 6 becomes positive 5x. Then stretch by a scale factor of 1 over 3. So scale factor is the reciprocal of coefficient of x. If stretch factor is 1 over 3, coefficient of x should be 3. So replace x with 3x, replace x with 3x. That is sine of negative 6x plus 15x. And I have suddenly taken this minus on the outside. What does it mean? How can I do that? So I have used this rule of trigonometry that sine of negative theta is minus sine theta. Got the idea? So that's how this thing is done. Uh, Let me do something of this type. The graph of y is equals to fx is transformed to the graph of y is equals to 1 plus f of half x. Describe fully the two single transformation. Just take care of this thing. Half x, half is the coefficient of x. So therefore, the scale factor has to be 2. The scale factor is 2. And then we are adding 1. So translation parallel to y-axis, translation vector 0, 1. Now let me, enough of transformation, don't take it to your head. So now let me just talk about few other things. So the tip number 7. So let me write tip number 7. That is, do not overthink about any topic. Some people will find transformation slightly tricky. The more you think about it, the more difficult it will seem. Some people will have issues with differentiation. Some people will have issues with integration and so on. So don't overthink about it. So now let's move on and let's talk about this thing, functions. So now, first of all, functions versus relation. What is the first thing? That is, how do you know it's a function or a relation? That's a vertical line test. Now, sometimes the examiner can ask such a basic question. If this thing is happening, vertical line test, if it cuts at one point, it's a function. If it cuts at more than one point, it's not a function. Function could be of two types, one to one, many to one. One value of x giving you one value of y, that's a one to one function. Many values of x giving you one value of y, that's a many to one function. Anything more than one, it's a many to one function. Now we apply the horizontal line test. We draw a horizontal line. If it cut at one point, it's a one to one function. A linear equation is technically a one to one function. A quadratic equation is a many to one function. A cubic equation is a many to one function. Trigonometric, many to one. Reciprocal, one to one. Exponential, one to one. Inverse of a function, we all know the trick. Some important pointers keep in handy. That is, only one to one function has an inverse. Sometimes we think about few things too much and we forget the basics. So that is why I'm reminding you of the basic. Only one to one function has an inverse. Inverse only exists for a one to one function. The graph of a function and its inverse are reflection of each other in the line y is equals to x. Therefore, a point a comma b becomes b comma a. The domain of original function becomes range of inverse function and vice versa. Very, very important. Take a screenshot, mark it down. Okay. These 3 pointers, mark it down, have a good look at this. So now over here, let me just share something. Why is it? So now this thing is there. Now the next 3 points, let me take a little bit sip of water and first have a good look. So now it says it is not necessary that the graph of fx and f inverse meet each other, but if they do, it meets at the line y is equals to x. So whenever there is intersection, you have to show at this line. The next 2 pointers, they are specifically related to quadratic. In order to find an expression for inverse function, it is necessary that the original quadratic equation is in the completed square form. Otherwise, how can you make it the subject? The inverse of a function has a square root sign provided original function is quadratic. If the domain is to the right of turning point, the square root has a positive sign and vice versa. Now, many to one function can become one to one function by changing the domain. What plays a crucial part in it? The turning point. Right of turning point, one to one. Left of turning point, one to one. This is with respect to a quadratic function. In trigonometry, for example, it's between one turning point and the other. Basic example, we have seen this in class. Fx, the domain, the range, flips a no point of intersection. 1, 4 becomes 4, 1. The domain becomes the range, range becomes domain, reflection in the line y is equals to x, and the inverse function. So now this thing is there. Let me talk about the basic idea, something about trigonometric function. Y is equals to sine x, y is equals to 2 sine x. Now 2 is on the outside, that is a stretch parallel to y-axis. The y coordinate doubles. So a point such as 90 degree comma 1 will become 90 degree comma 2. Or pi by 2 comma 1 will become pi by 2 comma 2. Y is equals to sine x and y is equals to sine 2x. Now 2 cycles in 360 degrees. Or we can say that since the coefficient of x is 2, the scale factor is half, the x coordinates are multiplied by half. Look at this. The x coordinates are multiplied by half. Now you can get things in the right context by studying functions first. Y is equals to sine x, y is equals to sine half x. Coefficient of x is half, scale factor is 2, the x coordinate is multiplied by 2. So if you have a point 90 degree comma 1, that becomes 180 degrees comma 1. Again, have a good look at this. Let's move on. Cubic equation and all these things. we are supposed to know just maybe a bit basic of this. Exponential function 2 raised to power of x, because now it's part of O-level maths. It was there before, now it has been emphasized a lot. If there is a negative sign on the outside, that's reflection in x-axis. 2 raised to power of negative x, or a raised to power of negative x, that's a graph of decay. And this is reflection of the red graph in y-axis. Reciprocal function, very, very important. The transformations comes a lot. Y is equals to k over x. There are two asymptotes. That is the horizontal asymptote and the vertical asymptote. There are no turning points. There are no x-intercept. There are no y-intercept. Y is equals to minus k over x. So original red one, that is first and third quadrant with respect to asymptotes. If there is a minus sign, then it's second and fourth quadrant. Now, what if k over x square reciprocal function? So now this is the first and the second quadrant with respect to asymptotes, minus sign, third and fourth quadrant. Y is equals to a over x, that is a simple reciprocal. A over x minus h raised to power of 1 plus k. And the square reciprocal, y is equals to a over x square. So that is the standard form. Now this standard form, as you can see, this looks very, very similar to the completed square form. That is the whole purpose. So now we can also do comparing coefficient. X is equals to h, that's a vertical asymptote. Y is equals to k, that's a horizontal asymptote. And a changes the steepness, so just ignore it. Positive, if A is positive, first and third quadrant with respect to asymptotes. If A is positive, second and fourth quadrant with respect to asymptotes. That means the simple one, that is the first and the third. And if there is a negative sign, that would be second and fourth. Again, if A is positive, that is first and second. Negative sign, that would be third and fourth. So now first mark the asymptotes, then draw the graph. Now have a look. And based upon this, there could also be something related with functions, related with domain and range. So this is 1 over x minus 2 power 1 plus 0. So k is 0, h is 2. So h is equals to 2, that's a vertical asymptote, that is x is equals to 2. And y is equals to 0 is the horizontal asymptote, since this is positive first and third quadrant, because this is a simple reciprocal. Fx is 1 over x minus 2 whole square plus 0. Now this is the square reciprocal. The same thing, but now this is first and second with respect to the asymptotes. Now one more thing. If they ask me about the range, this is 2. And if they say the domain is x is greater than 2, what is the range? So the y value, the lowest y value is 0. All the other y values are greater than this. So fx is greater than 0. That means you need the knowledge of sketch in and out. Something like this. Fx is 3 over x plus 1 raised to power of 1 plus 2. That is a over x minus h power 1 plus k. H is negative 1. K is positive 2. So x is equals to negative 1, y equals to negative 2. Focus on the y value for the range. So if I go to the right of this, if the domain is x is greater than negative 1, what is the range? The lowest y value is 2. Therefore, fx is greater than 2, because it's going all the way till infinity. Got the idea? Now, what if the domain is x is lesser than negative 1? So x lesser than negative 1, the y value is decreasing from 2. So therefore, fx is lesser than 2. It's not inclusive. So I think that is a lot about functions. Yes, there is this thing which is very important. That is first g and then first g, then f. That means fg. So if I put a sphere, I get a cube. I put a cube, I get a diamond. One single function that will do the job of changing the sphere to diamond. The name of that function is fg. The name of that function is fg. Now over here, this thing is very important. Composite function f of g of x will exist if and only if whatever output that you're getting from g, that is the range of g. So range of g is output of g will be a subset of domain of f, that is input of f. So now let me read it again. Range of g, that is the output of g, becomes a subset That means lesser than or equal to domain of f. So f of gx will exist if the output of g will becomes the input of f. Now let me show you the basic example. That is one of the famous examples, and all the examples can fulfill this criteria. So now over here, the function f is defined by such and such, x is less than or equal to a. The function g is defined by such and such, the domain is given. Find the largest value of a for which the composite function gf can be formed. Now, always make a habit of writing the statement. Gf will exist if the output of f becomes the input of g. Output of f is range of f. Input of g means domain of g. So range of f is just plugging in a over here. No need of any inequality as now. So this 3x plus 1 is 3a plus 1. It should be a subset of domain of g. It should be lesser than or equal to this value. So just plug in over here. Don't worry about this inequality. Just replace x with this thing. So the range fx is becoming x. Just remember this. So this 3a plus 1 is lesser than or equal to negative 1, and then you get this answer. So now that was one of the important things. Also, this is also important. Composite function, the same thing. First, f of g means first g, then f. Now, for f of g of x, domain of fg is the same thing as domain of g. And range of fg is the same thing as range of f. So whatever is coming out, whatever that you are putting in, based upon that, you will get the range of f. So I think that is enough of functions. It's 10:52, almost another hour. So now let me just put this thing over here, and let's relax a bit. So let's meet in 10 minutes or something. Okay, so now this is 10:52. So 10:52, this is break number 2. And let's meet at 11:02 p.m. So 4 topics are down. So 4 topics to go. Let's do it in one shot, inshallah ta'ala, around like 90 minutes or something. And let's hope for the level best. See you soon. Okay, I hope everyone can hear me now. Let me just double check my voice. And Okay, people, let's resume. Okay, people, now let's continue the journey. And where is my pen? Okay, it's right over here. So that was this thing. Second break is done. Now let me remove functions. And now let's go to what you call circle. That thing can be done. Let me just write over here. Coordinate geometry, line, circle. That is three parts. Yes. Let's start with circles. Okay. And the rest of the topics are comparatively easy after circles. Trigonometry, sometimes it becomes difficult. So now these are the main pointers. That is equation of a line, midpoint, slope, distance, angles. Angles is important. Circle, new syllabus from 2020 onwards. And let's have a look. Positive slope, negative slope, zero slope, undefined slope. Midpoint formula, that is based upon average. Do not underestimate anything. Parallel lines, the gradients are the same. Perpendicular lines, gradient multiplied to give you -1. Uh, this I already wrote over there. Slope, change in y over change in x. This is the important stuff. That is tangent theta equals to gradient of the line. Theta is the acute angle which the line makes with the x-axis with the horizontal. If there is a negative slope, just remove the negative sign and then work throughout. Uh, Angle between two lines. What if both slopes are positive? So this is just for explanation purpose. Line 1, the gradient is 2. Line 2, the gradient is 1. Based upon 2, find the angle. Based upon 1, find the angle. This angle is the difference between these two angles. No need to go into the geometry. Just remember the concept. Both slopes are negative. Remove or discard the negative sign. Discard negative, discard negative. It becomes case number 1. 3 gives you this angle, 2 gives you this angle. Angle in between, the difference between the two. What if one slope is positive, the other slope is negative? Then calculate each angle. All three should add up to 180 degrees. Half is giving me this. -1 is giving me 45. So therefore 5 would be 5 plus this is 180. Hence you find the value of 5. Perpendicular bisector, not only it's perpendicular, it passes through the midpoint. Line meets x-axis, y coordinate is 0. Line meets y-axis, x coordinate is 0. Of course, you know this, that the equation of x-axis is y is equals to 0. The equation of y-axis is x is equals to 0. A lot of people are unaware of this, unfortunately, but let me enlighten you. Height and base should be perpendicular, whether it's a right angle triangle, whether it's an acute angle triangle, then base is this and height is this thing. Not necessarily it will bisect. Maybe this has a length of 5, this has a length of 7. So this is not the perpendicular bisector. Yes, only if it's isosceles, then it becomes the perpendicular bisector. Or the base is over here. It's an obtuse angle triangle. The height is there on the outside, half base into height. Reflection, a very important concept that there is. So now over here, when we talk about reflection, let me just check one thing that I hope this is all good, all clear. Yeah. So now over here, A is a reflection of B in the green line. And then it says AM is equals to MB. That means if I have this point, If I have the mid value, I can find A using midpoint formula. Something like this, just the basic thing. C is the midpoint of the line joining such and such. The line through C perpendicular to AB crosses the y-axis at D. So one single English statement and lot of things are over here. So now we have this thing that find the midpoint, find the gradient of AB, do the negative reciprocal, find the equation. This equation meets the x-axis, y-axis at D. X coordinate is 0. That's the coordinate of D. Then use the distance formula. That is the basic stuff. A very famous question is this thing. That is x over a, y over b equals to 1. A and b are positive constants. It intersects the x-axis and y-axis at the points a and b respectively. The midpoint of AB lies on the line and the distance AB is this thing. So first of all, meets the x-axis at A, y coordinate is 0. Therefore, x is small a comma 0. Meets the y-axis at B, x coordinate is 0. Therefore, the coordinate of B is 0 comma B. 0 comma B, a comma 0. Midpoint, half A, half B. It lies on the line. Plug in place of x and y, you get the first equation. Then use the distance formula. Let me drink some water. So now over here, you have the other equation, and then you solve it simultaneously. Middle term factorization, that's the heart and soul of maths. You get two values of A, two values of B. It says somewhere over here, A and B are positive constants, so 0 is not positive. That's why we discard. Isosceles triangle. Triangle ABC has vertices such and such. Show that triangle ABC is isosceles, of course, the distance formula. No need of using the calculator, just work in the exact form. So AB is root 85, BC is root 85, CA is root 68. Two sides are equal, isosceles. Then it says, find the exact area. Exact means the answer in the third form or fraction form. So now either I can use this matrix method, start from any point, go anti-clockwise. So if I start from A, then A, B, C, and A, B, C, and A, X, Y, X, Y, X, Y, X, Y. You multiply in this order, add it up. You multiply in the blue order, add it up. There is a minus sign in the middle. This comes out to be 34 square units. Minus just means I might have taken in the clockwise direction. So that could be nothing wrong with that. Just ignore the negative sign. The other one is that draw a triangle, draw a diagram. And what we can do is that we can either find using half AB sine C if I want to use cosine rule. But what I'm doing is that since it is isosceles, which two are isosceles? That is AB and CB. Therefore, now if I drop a perpendicular, it will pass through the midpoint. So now the midpoint of A and C is 2 comma negative 2. Let me use B, let me use M, that will become the height. So BM is root 68, that becomes the height. And half into root 68 into root 68. So AC is also root 68. BM is also root 68. So therefore, this answer comes out to be 34 square units. So the square root cancels out and you get an exact answer. The reason why they use the word exact was that do not use a calculator when evaluating root 68. This is the formula for a quadrilateral if someone needs it. Now let's move to this thing. Yes, this is important. This one shows, the diagram shows the curve y is equals to x minus 1 raised to power of half and the points A and B lying on the curve. Find the equation of line AB. That is nothing special. Showing all necessary working, find the equation of tangent to the curve which is parallel to AB. So let me use the gradient of AB. Gradient of AB, that is 2 minus 0, 5 minus 1, that is 2 over 4, which is half. Now it says find the perpendicular distance between the line AB and the tangent parallel to AB. So now where is the tangent parallel to AB? So what we can do is that we can write y is equals to x minus 1 raised to power of half dy by dx, that is half x minus 1 negative half, derivative of bracket is 1, that is 1 over 2 root x minus 1. Now let me equate this to half. So 1 over 2 root x minus 1 is equals to 1 over 2. So 2 cancels out. Basically, root x minus 1 equals to 1. Therefore, x minus 1 is 1 square. Therefore, x comes out to be 2. That means when x is equals to 2, you will be getting that tangent. Now, when x is 2, y is 2 minus 1 raised to power of half. 2 minus 1 raised to power of half. That is 1 raised to power of half or 1. So therefore 2 comma 1 is the point. So now 2 comma 1 somewhere over here. Let me just draw a rough line. That is something like this. This is the line AB. And let me draw this line over here. Let me change the color. Like this. Okay, so now these two lines are parallel, and this is the point which is 2 comma 1. Let me call this point as Q. Now it says find the perpendicular distance between line AB and the tangent parallel to AB. So what I can do is that I can find this distance from this point to this line. So what I can do is that I can either use the angle concept or I have the gradient of AB. So the gradient of this line should be that is half and this is negative 2. So let me call it R. So Q is 2, 1. Gradient is negative 2. Let me find the equation of this line. That is y minus y1 is equals to minus 2x minus x1. Minus 2x plus 4 plus 1, y is equals to minus 2x plus 5. That's the equation of QR. Solve it simultaneously with the equation of AB. Equation of AB is half x minus half. So equation of AB is half x minus half. So solve it simultaneously. Half x minus half, that is x minus 1 over 2, that is minus 2x plus 5. X minus 1 is minus 4x plus 10. 5x is equals to 10 plus 1 is 11. X is 11 over 5. When x is 11 over 5, y is minus 2 into 11 over 5 plus 5. That is negative 22 over 5 plus 5. 25 minus 22, that's 3 over 5. So the coordinate is 11 over 5, comma 3 over 5. That's the coordinate of R. And then Q is given as 2, comma 1. So just use the distance formula. So therefore, this is 2 minus 11 over 5 whole square. This is 1 minus 3 over 5 whole square under root. That would be the perpendicular distance QR. That's the perpendicular distance between the lines, something like that. We can also use the concept of angle. If this is half, I can find this thing as theta. So now this thing is theta. And based upon that, I can find this distance by drawing a tangent and a right angle triangle and things like that. For right now, this is good. So now let's move on and let's move to the circle equation. Circle equation, the standard form, that is x minus h whole square, y minus k whole square is r square. That is how it came into being. This is the completed square form. You can plug in, you can do comparing coefficient, get hk and radius. If the center is given, radius is given, you can write down the equation. If point and center is given, you can find the radius yourself and then write down the equation. Quadratics, the general form into the completed square form, the same thing over here. Circle equation, the general form to the completed square form. Now, first of all, have a good look at this. What exactly is happening? Think for yourself. So now over here, You grab the x square with the x square, you grab the y square with the y square with the y, and then you apply the same process. Just focus on this. That is x square minus 10x. First add, then subtract square of half the coefficient of x. Now, once this is done, do the same thing with the y. Now, it's necessary that in order to do the completing square method, the coefficient of x square and y square should be 1. That is always the case. Rewrite the first three terms as a perfect square. That is this. Rewrite the first three terms as a perfect square. Transfer this to the other side. So this is x minus h whole square, y minus k whole square is r square, h is 5, k is negative 6, r is 7. Show that the circle passes through this point. Just plug in place of x and y, both sides should be equal. If the endpoints of a diameter are given, find the mid value to one of the endpoints. That is what? That is the radius of the circle. Find the midpoint of AB, that's the center of the circle. From the center to any point on the circumference, that's the radius, and then write it down. Some important properties which will be coming up one by one. Determine the equation of tangent to the circle with this equation at the point A 2, 5. Now, when such a thing is given, you need the center of the circle, you need the completed square form. Then a small diagram will do the job. From that center to the point A, that is the gradient. You find it. Therefore, the gradient of the tangent will be negative reciprocal. Find the equation of the tangent. And let's move to this one. Show that OB is a diameter of a circle which passes through the point O, A, and B. So OA, find the magnitude. OA, find the gradient. AB, magnitude, gradient. Similarly, BO, magnitude, gradient. Now you can prove it in two ways. Now stay alert. If it's a right angle triangle, it fulfills Pythagoras theorem. The biggest side square, which is technically the hypotenuse square, should be equal to the sum of the squares of the other two sides. So 80 equals to 40 plus 40. Root 80 is what? Root 80 is BO. So the biggest side is the diameter, that is the hypotenuse. And angle opposite to OB is 90 degree because there is this property, diameter produces a 90-degree angle at the circumference. And then if you want to do it using the gradient method, if two gradients multiply to give you -1, that particular angle is 90 degrees. OA, AB. What is the common alphabet? That's A. So common letter, that's a 90-degree angle. Length opposite to A is OB. So do it this way or that way. Both ways are good. And then you're back to concept number 1. Find the mid value, find the distance, use the formula. Very important property. If there are 3 points lying on a circle, and this time they're not forming a right angle triangle, or maybe they're forming a right angle triangle, we can still use a chord property. AB, find the midpoint, find the perpendicular bisector. BC, find the midpoint, find the perpendicular bisector. Where the two bisectors meet, that is the center of the circle. AB, midpoint, gradient. BC, midpoint, gradient. Negative half becomes positive 2 becomes negative half. Using positive 2 and this point, find the equation of the perpendicular bisector, find the equation of the perpendicular bisector, solve simultaneously. 3, 0 is the center. Find the radius, find the equation of the circle. There are concepts related with more basic geometry. So it's all about geometry right now. So now it says there is a red circle, there is a center 3 minus 3, there is a radius 2. From the outside point till the center, find the distance. If I subtract the radius, I'll get QA. If I add the radius, I'll get QB. Now look over here. Least and greatest distance from outside point to a circle. They have not asked this for a long time. Maybe they can ask it now. This is the center of the circle. That is 3 minus 3. That is the outside point. Find the distance, which is 5 units. The radius is 2 units. For the least distance, the distance from outside point to the center, subtract radius. For the greatest distance, add the radius. The same type of question over here. Something to do with quadratics. Quadratic equation in line, the same concept can be used with circle in line. Circle and line meets at 2 point, discriminant is positive. Meet at 1 point, discriminant equals to 0. Does not meet, discriminant is negative. If it says circle meets the line or line meets the circle, so therefore b square minus 4ac is greater than or equal to 0. Now, there are some past paper questions. That is the point A is 7, 1, B is 7, 9, C is 1, 9. Find the equation of the circle, find the equation of tangent to the circle at B. So now it so happens that they are forming a right angle triangle, and it was very, very obvious that they were forming a right angle triangle. It was nothing fancy because 1979, the line is y is equals to 9. 7971, the line is x is equals to 7. So line parallel to x-axis, line parallel to y-axis, naturally they are perpendicular. Secondly, what needs to be done? I have done it using Pythagoras also. As such, there was no need. And this has to be the diameter. Find the midpoint, find the radius, find the equation of the circle. Find the equation of the tangent, nothing special. Find the x coordinates of the point A and B where the circle intersects the x-axis. They ask it a lot, therefore y coordinate is 0. So y coordinate is 0, y coordinate is 0, completed square form. You get the center and then solve simultaneously. Point of intersection of tangents to the circle at A and B. For this, you need the completed square form. First thing first, line meets x-axis, y coordinate is 0. You get this quadratic equation, you get coordinates of A and B. Then you do the completed square form, you get the center of the circle. You don't need the radius as such. Now draw a diagram. Now this is very important. Drawing a diagram is very, very important. I cannot overemphasize this. So now what happens is that when this thing is the scenario, let me just flip this thing. Okay, so now over here, we have the center. We have a realistic diagram. Find the gradient. Negative reciprocal would be this. From C till B, find the gradient. Negative reciprocal will give me this. Now it so happens is that this gradient is minus 1/3. This gradient is positive 1/3. Very important. These two lines are not perpendicular, but they have the same acute angle with the x-axis. This has a positive slope. This has a negative slope. That is what I want to emphasize it. So therefore, at A, at B, at this point, they are forming an isosceles triangle. Similarly, an isosceles like this. And what else are we looking for? We solve it simultaneously. We find the point of intersection. Again, another important question that uses the concept of reflection also. The point A has coordinates 1, 5. The line L has gradient such and such and passes through A. So it passes through A and the circle has radius 511 and radius 52. Show that L is a tangent to the circle. So now over here, what needs to be there? The gradient is 511. I think I've solved it over here also. Yeah. So first of all, C is 511. A has 1, 5. The gradient is 3/2. Gradient of the tangent should be negative 2/3. It passes through A. It passes through A. Find the equation and show that L is the tangent. So you have this gradient. It passes through A. So I think the gradient does the job. And the radius is √52. I just calculated it extra. Now find the equation of the other circle of radius √52 for which L is also a tangent. Now this is the concept of reflection. And I think I've done a much better job over here. This is 511. This is A15. This is C2. So in other words, this has to be the perpendicular bisector. So take the x coordinates, take the average, take the y coordinate, take the average. You find the coordinate of C2. In translation, in reflection, the area is not changing. So therefore, the radius remains the same and the center only changes. Radius remains the same, center only changes. That was special about this thing. Now, this was a nice question. Let me explain it to you. Now, this thing says the diagram shows a circle with equation x squared plus y squared minus 6x plus 4y minus 27 is equals to 0 and the tangent to the circle at point P. The tangent to the circle at P meets the x-axis at A, meets the x-axis at A, and the y-axis at B, and the y-axis at B. Find the area of the triangle OAB. So this is OAB, that's the area of the triangle, that's easy. First thing, circle equation, get the center, get the radius. Step 2, that is this thing about the tangent because I need coordinates of A. So this is C, this is P. Where is P? P is this one. C is somewhere over here. Find this thing, then the negative reciprocal. So the gradient is positive 3, gradient of tangent is negative 1/3, coordinate is 5, 4. Line meets x-axis, y coordinate is x, line meets x-axis at A, y coordinate, y-axis at B. So coordinate of A is 17, 0, coordinate of B is 0, 17 over 3. And they are asking equation, for some reason I haven't done over here. Step 5 is upstairs, half into base into height. That's this answer. Leave the answer in the exact form. Now it further says point Q and R also lie on the circle such that PQR is equilateral. So PQR is equilateral. And find the exact area of this triangle. So now if it's equilateral, this angle is 60 degrees, this angle is 120, angle at the center is twice the angle at the circumference. So now from the center till P, I can find this thing. That should be the same thing as CQ. That should be the same thing as CR. So if I use this length, if I use this length, if I use this angle, and I find the area of this triangle, that should be the same as this. That should be the same as this. That's the knowledge that I've used. Focus on CRQ. So this angle is 120 degrees, half AB sine C, half into root 40 into root 40 into root 3 over 2. Root 40 becomes 40. 40 divided by 4 is 10, 10 root 3. So multiply by 3, that's the area of this thing. So I think that's enough of coordinate geometry, circle and everything. That thing is done. Let me pick something like, where is trigonometry? So now quadratic is done. Let me first open up trigonometry. And then let me open up this thing, which is CM, and then APGP, and then a little bit of binomial. So I think I've done the difficult topics first so that you people don't get tired that much. And those who can retire and take a rest, they can skip, no issue. And that's binomial. Okay. Now let me focus on trigonometry. In trigonometry, the main point is this, the exact trigonometric ratios. Very, very important. Sine of 30 is cos of 60, cos of 30 is sine of 60, tangent of 30, tangent of 60 are reciprocal. This is not written in the formula booklet. You have to remember it. And of course, you have done so much that you remember it by now. Tangent of 45 is 1, sine of 45 is 1, cos of 45, sine of 45 is 1 over root 2, cos of 45 is 1 over root. Then we have anti-clockwise angles are positive, clockwise angles are negative. Angles are measured with respect to x-axis, quadrants are labeled. First, second, third, fourth. First quadrant, all the ratios are positive. Second quadrant, only sine. Third quadrant, only tan. Fourth quadrant, only cos. All the angles are related, like 30 is related to 150 in the second quadrant, 210 in the third quadrant, and then 330 in the fourth quadrant. Similarly, 60 is related with 120, 240, and 300. 45 is related with 135, 225, and 315. Then in the first quadrant, theta is the same thing as the basic angle. Second quadrant, 180 minus basic angle. Third quadrant, 180 plus basic angle. Fourth quadrant, 360 minus basic angle. Some conceptual questions take care of the quadrant, but the triangle that you will draw, that will have all the positive ratios. So that is the important thing over here. Let me drink some water. Okay, now look at this one. It's in the first quadrant, sine, cos, tan is positive. Draw a triangle with the positive ratios. If sine is given, that means they have given you opposite and hypotenuse. If cos was given, they would give you adjacent and hypotenuse. If tangent was given, they will give you opposite and adjacent. And then use Pythagoras theorem. So this triangle is based on length. Length is always positive. Yes, based upon the quadrant, you will apply the positive, negative later on. Second quadrant, sine theta is positive, but cos theta will be negative, tangent theta will be negative. You can also get a symbolic question like this. Theta lies between 180 and 270. Tangent theta is k. K can be written as k over 1. This is k. This is 1. Hypotenuse, that is 1 k squared plus 1 squared, the whole thing under root. Do not open up the bracket because you cannot. Sine theta, this over this. Cos theta, this over this. It's in the third quadrant. Therefore, sine is negative, cos is negative. Only tangent is positive. Then we have this very important relationship. Sine of 180 minus theta, sine theta. Cos of 180 minus theta, negative cos theta. Tangent of 180 minus theta, negative tan theta. Then we have this relationship for negative angles. Negative angle, we get the idea from first and fourth quadrant. As such, it's applicable everywhere. Cos of negative theta is the same thing as cos of theta. Sine of negative theta is minus sine theta. Tan of negative theta is minus tan theta. Rationalization, you should know how to do it. Degrees and radians, that's how the conversion happens. The same thing that is written, just take a screenshot. The same thing that's written with degrees, it's written with radians, nothing special. Okay. Trigonometric identity, sine square theta plus cos square theta equals to 1. Now keep in mind, it could be theta, theta, it could be 30, 30, it could be 60, 60. It could be x and x, it could be 2 theta and 2 theta. So don't get confused with that. Tangent theta is sine over cos. Sometimes this kind of question do also come. You can use it, you can solve it using the triangle thing. You can solve it using the ratio thing. Basic sketches, you get the idea. It's 5 pointers, 0, 0, 91, 180, 0, 270, negative 1, 360, 0. Transformations you have already studied. Cosine, it's 1, 0, negative 1, 0, and 1. One cycle in 360, one cycle in 360. Tangent, this red and this green, that's one cycle. This red, this green is the other cycle. Sine x, cos x, tangent x, all on one page. Now, when we are solving for sine x equals to 0, a sketch is beautiful. Sine x equals to 1 from the sketch, sine x is negative 1 from the sketch. Tangent x is equals to 0 becomes sine x equals to 0 after simplification. Cos x is equals to 0, 2 values. Cos x is equals to 1, 2 values. Cos x is negative 1, 2 values. So basically for these 7 values, just use a basic sketch. Basic exact trig ratios, quadrant and everything, trig equation, the 4-step method. For example, sine theta is 0.5. Theta lies between 0 and 360 degrees. So sine is positive. That means the first and the second quadrant. Range unchanged because this is theta, this is theta. Basic angle alpha, acute angle with x-axis, always calculated with a positive ratio. First quadrant theta is alpha, second quadrant theta is 180 minus alpha. Now some people, they asked question about some negative angle or something. So let me just move ahead and show you something. Sometimes you have to take common, that's the first priority. If common is not there and sine and cos are there, create into tangent. Tangent x negative 1, that means second and fourth quadrant. No modification in range. Basic angle is calculated with the positive ratio and then the angle. Now, let's say I'm looking for some question that has this negative thing in it. Or then I'll just make my own question. I thought there were some of them. Now, also, let me just focus on this one. Then I'll go to the negative angle. For example, this worked example 11. Have a good look at this. And then compare it with example number 12. First, look at number 11. How did I modify the range in cosine? Do a bit of brainstorming. So now, what is so special in this question? That is, looking for my glasses. So now over here, sine 2x plus 10 degrees is equals to 0.5. And first and second quadrant, 2x lies between 0 and 720. 2x plus 10 degrees lies between 10 and 730. Sine alpha is 0.5, alpha is 30 degrees. First revolution, two answers, another revolution, another two answers, because it's from 0 till 720. So when you have 30 degrees over here, so you go one more revolution and you add 360. 150, add one more revolution, 510. And these are the answers. But now something has changed. I've changed 10 degrees to 40 degrees. The modified range is 40 till 760. Basic angle is still the same. So we have 30, we have 150, we have 390, we have 510, but compare with this. 30 degrees is out of the range. Find an alternative. The alternative will be in the same quadrant. So 30 is giving me 390, add 360, 750, it's within the range. Just make x the subject, subtract 40, divide by 2. Final answer should be within this range. Another very important question. Cos of 2x minus 30 degrees is 0.5. And it's between negative 30 and 690. Basic angle is 60, 60, 300, 420, 660. No issue. Everything within the range. I changed it into negative 70. Modified range is between negative 70 and 650. Basic angle is still the same. Now 60, 300, 420, 660. This time it's exceeding the last thing. Now, last time we added 360 because there was liberty and freedom of going ahead. This time there is no liberty. So that is why 660 is the same thing as 60 degrees clockwise, which is negative 60. So yes, a negative angle occurs over here. So negative 60, 60, 300, 420, add 70 to each one of them and then divide by 2. That's the final answer. Angle in degrees, work in at least 2 dp, final answer 1 dp unless otherwise stated. Exact answers, no accuracy issues. This one was a nice question. Expect something like this. It says solve the equation 2 cos x plus 3 sin x is equals to 0 for x between 0 and 360. Sketch on the same diagram the graph of 2 cos x. So 2 cos x, one cycle between 0 and 360, that's the red one. Negative 3 sin x, that is reflection in x-axis, maximum 3, minimum minus 3, flipped up. Use your answer to part 1 and 2 to find the set of values for which 2 cos x plus 3 sin x is greater than 0. In other words, the red graph is greater than the green graph. Greater means above. So red is above the green. So that is one point of intersection, 146.3. So between 0 and this thing, the red is above the green. And this value should not be inclusive because at this point they both are common. If this was equal, I would put an equal sign. So 0 is inclusive, 146 is not. And from this value, 326 onwards, red is greater than this. So again, this value is not inclusive. This value is yes, included. Okay, let me do this question. Express the equation sine 2x plus 3 cos 2x. So this is sine 2x plus 3 cos 2x is equals to 3 sine 2x minus 3 cos 2x. So transfer all the sine to the left-hand side. So this is 1 minus 3 negative 2 sine 2x. Transfer all the cos to the right-hand side. So that is negative 3, negative 3, negative 6 cos 2x. Divide by cos 2x, divide by cos 2x. So therefore, what do we have? We have 2 tangent 2x is equals to 6. Therefore, tangent 2x is equals to 3. It's of the form tangent 2x is equals to k. The value of k is 3. Hence, solve this equation from minus 90 to 90. Now, let me start the 4-step solution. The first one is the quadrants. Tangent is positive, so first and third quadrant. The second one, the modification of the range. So x lies between negative 90 and positive 90. But since this is 2x, so 2x lies between negative 180 and positive 180 degrees. And then the basic angle. So this is the modification of range. And then the basic angle, that is tangent of alpha is 3. I think it's 71.57 degrees. Just double check. I think it's 71.57 degrees, 71.6. So they have rounded it off first. Let me keep it unrounded for right now. Then it says minus 90 to 90. Now, as far as the angle is concerned, so now let me draw a diagram and let me first just evaluate it normally. So now I'll say the final answer. We have this quadrant that is second and this is positive. So this is first and third quadrant. So if I just think about first and third quadrant, I'll write 2x is equals to the first quadrant is 71.57 degrees. And this is 360 minus 71.57 degrees if we were going from 0 to 360. So this is like this. This is one angle and this is the other angle. Now this first quadrant has no issue. This is good. But this third quadrant has my bad. This is not this one. So let me grab this thing. The first quadrant has no issue. The third quadrant has an issue. That is 180 plus basic angle. This is third quadrant. This is theta is alpha. Now over here, since we are going clockwise, so let's go this way. So first write this thing. This is 180 plus 71.57. So let me grab a calculator. 180 plus 70. That is 251.57. So this is 71.57 and this is 251.57. But we don't need this. We need this thing. That is 360 minus 251.7 with a negative sign, or 180 minus this basic angle. So let me grab the calculator. That is 251.57 minus 360. That is 108.43. So this is 108.43 degrees with a negative sign. So 2x is equals to negative 108.43 and positive 71.57 divided by 2. That is 54.215. And 71.57 divided by 2, 71.57 divided by 2, that is 35.785. Okay, so now over here, this is negative 54.2. This is negative, of course, negative 54.2. This is 1 dp. And this is 35.78. That is 35.8 positive. That's also 1 dp. That is the final answer. That is the value of x. So that's how this question is also done and dusted. And let me just double check something. Something in terms of pi. Something to do with identity. 1 plus sine, 1 minus sine, minus 1 minus sine, 1 plus sine is 4 tan over cos. So if you want, you can tell the examiner, let sine x be written as S, let cos x be written as C, and then work it out. 1 plus S, 1 minus S, 1 minus S, 1 plus S, cross multiply with a negative sign in the middle. So we are left with 2s plus 2s, that's 4s. 1 minus s squared is c squared. So 4s into 1 over c, 1 over c. Sine over cos is tan 1 over cos remains as 1 over cos. So now this box equals to this thing. This is the same box equals to 8 tan x. So 4 tan x over cos x is 8 tan x. 4 tan x is equals to 2 tan x cos x, and always take common. Remember, taking common is the first priority. So therefore, tangent x, that is taken common, 1 minus 2 cos x. Tangent x is equals to 0, sine x over cos x is equals to 0, sine x equals to 0. It's in radians. So this is 0 and pi and 2 pi. What is the range? The range is 0 till half pi. So 0 till half pi is 0 inclusive? Yes. So therefore, this is the only answer from here. Then the fourth step method, that is the first and fourth quadrant, modification of range, there is none. Basic angle is pi by 3. Therefore, x is equals to pi by 3 and 2 pi minus pi by 3. But this is out of the range, so only one answer. So one answer from here, one answer from here. That is the final answer. So that completes trigonometry. Circular measure. I think the basic, everyone knows it. The degree radian thing, make sure the calculator is in the radian mode. Sine of pi by 6 is half, cos of pi by 4 is root 2 over 2, tangent of pi by 3 is root 3. Then the formulas, they all have to be in radians. The angle has to be in radians. So S is r theta, S is the arc length, theta is in radians. Area is half r squared theta, again theta is in radians. And we have all these ratios over here. That is the obvious part. And let me just double check one thing. Okay. Now over here, sine of pi minus theta is sine of theta. And let me just double check this thing. Sine of pi minus theta is sine theta, cos of pi minus theta, negative cos theta, tangent of pi minus theta, negative tan theta. Similarly over here, similarly over the exact ratios. Now over here, we have to be very, very particular about strategy. So now let me go over here. That is the live thing, tip number 8. So let me add something over here. So now this is tip number 8. That is in circular measure, take care of radians, take care of calculator, take care of formulas that are made for radians. What else is there? First, strategize. That means think, label, decide, then whether it's in the exact form or it's in significant figures, and then work it out. For example, if we are focusing over here, it says the diagram shows a circle with radius r and center O. The line PT is tangent to the circle at P and angle POT is alpha radians. The line OT meets the circle at Q. Express the perimeter of the shaded region in terms of r and alpha, and then r and alpha are given. The values are given, find the area of the shaded region. So perimeter in terms of symbols, and then area in terms of values, and those values are the exact ones. So now, when we talk about sine and cos and tan, so a triangle is there. That triangle is this thing. This is the base R with respect to alpha. This is the adjacent. This is the opposite. And this is the hypotenuse. So cos of alpha is R divided by, cos of alpha is OP divided by OT. So that's the hypotenuse. So if I make OT the subject, that's R over cos alpha. If I subtract the radius, I'll find QT. So I'll find QT, that's over here. And then tangent of alpha is PT over OP. Tangent of alpha is PT over OP. So I can make PT the subject. So I need the green line, I need the blue line, I need the arc length. The arc length is over here, SP is equals to R alpha. So the purple the green, the blue, add it all up. Uh, PT can be found. OP is 10. Area of triangle can be found. Half AB, half base into height, area of sector, and then subtract. Something like this. The diagram shows a metal plate ABCD made from two parts. The part BCD is a semicircle. The part BCD is a semicircle. And the part DAB is a segment of a circle. DAB is a segment of a circle with this thing. So now, first of all, BCD, that is this thing, and DAB, that is the segment because this thing has been cut off. So that segment is basically this triangle plus this major sector. Angle is 1.2. First of all, it's saying show that the radius of the semicircle is this much. This is 10, this is 10, this is angle. Apply cosine rule, find the total length, and then divide by 2. Or draw a perpendicular. This is 0.6 radians, and find half of this. That is the radius. So sine of 0.6 is r over 10. You can also do that. Now, which way have I done it? I have done it using cosine rule. Now, the next thing, find the perimeter of the metal plate. So find this circumference of the semicircle. That is half of 2 pi r. Find the arc length of the major sector. That is this thing, but the angle has to be 2 pi minus theta, 2 pi minus this thing, 3.142, that is pi. 6.284, that's 2 pi. That's what I've used over here. Perimeter of the metal plate, that is the major sector, plus this thing. Area, that is the area of the sector, area of the triangle, area of the semicircle. Area of semicircle, area of triangle, area of major sector, add it up. So that's enough for circular measure. Now, AP and GP. Now, the last two basic topics are there. And let's just focus on the main pointers. Arithmetic progression, the difference is constant common. That's a term formula. That's a sum formula. There is also this sum formula. Sometimes, most of the times, it's about simultaneous. The 12th term of an AP is 17. So A plus 11D is 17. The sum of first 31 terms is 1023. 31 over 2 to A plus N minus 1 into D, that's 1023. Solve it simultaneously. You find D, you find A. Find the 31st term. Therefore, the 31st term is A plus 30D. Sometimes they give more marks. Sometimes they give less marks. Just focus on the answer. Method, just follow my way. No step should be omitted. Geometric progression, the ratio is common, second over first, third over second, and so on. Term formula A r power n minus 1. Sum formula A 1 minus r power n 1 minus r. An infinite series has a finite sum if common ratio lies between minus 1 and 1, sum to infinity. This is also called a convergent series. So this is a convergent series. That means it's related with sum to infinity. So now, special question. The first, third, and 13th term of an arithmetic progression, or also the first, second, third term of a GP. The first term of each progression is 3. Find the common difference of the arithmetic progression and the common ratio. Now, in such questions, they do write this warning sign. The common difference should not be 0 because all the terms would be alike, and the common ratio should not be 1. All the terms would be alike. So from the AP, this is the first term, this is the third term, this is the 13th term. If they are forming the first 3 terms of a GP, the second divided by first should equal third divided by second, and you find 2 values. Accept this one, reject this one. R is this thing. So R is just plug this D over here and find the value of R. Something like this, a word problem type. A cyclist completes a long distance charity event across Africa. The total distance is this much. Sum of all the terms would be this much. He starts the event on May 1st, cycle 200 kilometers on that day. On each subsequent day, he reduces the distance by 5 kilometers. How far will he travel on May 15th? So reduces, that means the common difference is -5. First term is 200. Sn is this much. May 15, that is the 15th term because first term, 15th term, T15. And then on which date will he finish the event? So n comes out to be, that is b squared minus 4ac. N comes out to be 20. So only solution is 20. Because if I take 61, that will be the negative term. How is that possible? He cannot go back in that direction. So now 20 is May 20th. He will finish this thing. Now let me focus on such things, which is very important. A percentage question related to salary, aid, grant, bonus, scholarship, that is a GP question. That percentage is not common ratio. If it's an increase, R is 1 plus the percentage value in decimals, that's the common ratio. If it's a decrease, R is equals to 1 minus the percentage value in decimals, that's the common ratio. So if this is 2.5% and if it's an increase, so this is 1 plus 2.5 over 100. And let's say if it's a decrease, so 1 minus 2.5 over 100. Years, pages, calculate the difference, add 1. 2005 till 2014, take the difference and add 1 because it's inclusive, or count on your fingers. This one, very important question. The first two terms of an arithmetic progression are 16 and 24. Find the least number of terms, the progression which must be taken for the sum to exceed this much. So now in one of the very recent paper that I solved and uploaded the video, I have solved a similar question like that. Do check it out. The first term is 16. Second term is 24. Common difference is 8. Sn is greater than 20,000. Solve this inequality with the equal sign. Of course, you will use a quadratic formula. One value will be negative, discard it. The other value, always round it up. Why do we round it up? Because if we take 69, the total will be lesser than 20,000. If we take 70, it will be greater than 20,000. Something like a simultaneous type. A geometric progression has a second term of 12, the sum of infinity of 54. Find the possible values of the first term of the progression. Second term, AR is 12, make A the subject. Sum to infinity is A over 1 minus R, make A the subject. Equate, solve this quadratic, you get two answers. Both answers are possible because both common ratios are between -1 and +1. Same type of question. Now, the last question of this, the first, second, and third term of a geometric progression are 3k, 5k minus 6, and 6k minus 4 respectively. Show that k satisfies this equation. So if it's a GP, the common ratio is the same, just like what we did. Showing all necessary working, the exact values of the common ratio corresponding to each of the possible values of k. So now you solve this and you get k as 6 over 7 and k is 6. One of these ratios give a progression which is convergent. Find the sum to infinity. If I plug in k is equals to 6, I get r as 4 over 3. If I plug in k as 6 over 7, I get r as minus 2/3. So therefore, which is the right one? Therefore, reject this one. So therefore, this one is rejected. This one is accepted. Since convergent series, sum to infinity, the common ratio should lie between -1 and +1. Something to do with trigonometry. Yes, this cannot be what you call skipped when we have done so much work. Why skip this one? The first and second term of an arithmetic progression are such and such, respectively, where theta lies between 0 and pi by 2. They have written it because all the terms are positive. Show that the common difference, all the sine, cos, tan is positive. Show that the common difference is this. Find the exact value of the 13th term. So I think the first is this thing. So AP, common difference is T2 minus T1 minus T square over C square minus 1 over C square. Let me take minus common. Let me take C square common. So 1 over C square with a negative sign is T square plus 1. T square plus 1 is sine square over cos square plus 1. Take LCM, sine square plus cos square is 1. So this is negative. This is C square. This is C square minus 1 over C4. Got the idea? Find the exact value of the 13th term when theta is pi by 6. When theta is pi by 6, cos of pi by 6 is root 3 over 2. And this is 1 over cos of pi by 6 whole square, 1 over root 3 over 2 whole square. This comes out to be 4 over 3. And the common difference was already simplified. That is minus 1 over cos square into 1 over cos square into 1 over cos square. So this is 1 over cos square is already known. That's 4 third into minus, which is negative 16 over 9. 13th term, that is a plus 12d, and this is an exact answer. So now this thing is also gone, and the very last topic, that is binomial. And yes, the marathon, the 360-degree overview was really worthwhile. Binomial expansion. So now down to the last topic. Yes, thak gaye bilkul. Not an easy task. 1 year syllabus, everything, the crash course, the 60 hours, doing it in 3-4 hours. That's not easy. So now binomial, 1 plus x whole square, that is 1 plus 2x plus x squared. That's a basic idea. If there is a negative sign, the sign alternates. Number of terms is 1 more than the power. And of course, you will be using this thing in S1 also, inshallah ta'ala. Once you have an amazing paper tomorrow, then we will be focusing on S1. How to find n? Yes, don't worry. Aa jayega wo bhi. So now NC1 n over 1, NC2 n minus 1 over 2 into 1, NC3 n minus 1 n minus 2 over 3 into 2 into 1, and so on. Common values. Okay, let's focus on this. Find the coefficient of x4 and x5 in this expansion. So now coefficient of x4, NCR, and this b raised to power of r. A coefficient of x5, NC5, 5c5 minus 2x raised to power of 5. The coefficients are there, and these two brackets are multiplying. So 1 plus px is 1 plus px, and the two relevant terms are x4 and x5. Why are they relevant? The constant will multiply with x5. That will give me x5. The x will multiply with x4. Similarly, the same kind of question, this time there is a positive sign. So now positive equals to this, and then you solve. Acha ji. Again, selective multiplication. Yes, this one, a lot of people, they ask this question. 1 plus y raised to power of 6 and ascending powers of x, as far as the term in y square. That is simple. Now, instead of y, they have inserted this. The coefficient of x square is this much. Find the value of the positive constant. So wherever there is y, insert it. Wherever there is y, insert it. So now, this thing, just multiply it out. Expand and multiply it out. Just collect the x squared term and equate it to 48. Only except because it says so that p is a positive value. Now, the very important thing, जो जिसके आने के chances होते हैं, अच्छा जी, beta, I can read your comments. Give me some time. Let me first go with my flow and then look at it. Okay, now the 3-step method. Cannot figure by observation what is the position of the term in the series. We cannot figure out what is r. To find unknown r, the 3-step method is there. Find the term independent of x in this expansion, x minus 3 over 2x raised to power of 6. First of all, write it down, NCR, and then a raised to power of n minus r, b raised to power of r. 6CR, b raised to power of r. So 3 over 2 is 3 over 2, negative is negative. This x is written upstairs, minus 1 into r, 1 into 6 minus r. Get the powers of x and equate it to power of required term. So since they're asking for independent of x, that means the constant term, the power is 0. R can come out to be 0. That means the first term, R will always come out to be positive integer, cannot be negative, cannot be a fraction. Once you get the value of R, place R where it belongs and simplify. That's your answer. Now, let me just go to the very last thing that a lot of people of you have requested. That is this thing, that unknown thing. Now, first, let me create a whole question. And that is this thing over here. Let me write it. 2 plus 3x raised to power of 5. And let me write three terms, and then I'll create that question. So that is 5c0, 5c1, and 5c2. I just need the first three terms. So this is 2, this is 3x, this is 2, this is 3x, this is 2, this is 3x. The power of 0, this is 0, the power of 1, and the power of 2. And this is 5, and this is 4, and this is 3. Now let me simplify. 5c0 is 1, 2 raised to power of 5 is 32. This is 1, 5c1 is 5, 2 raised to power of 4 is 16. This is 3x. And 5c2 is 10, and this is 8, and 3 square is 9. So this is 32. This is 80 into 3, that is 240x, and that is 720x square. Now let's make it a question like this. We have 2 plus bx raised to power of n, the first three terms. Now I'm making an exam type question. So now this is 32 plus 240x plus 720x square. Now find b and n. Now n is very easy. Let's say that this thing is also unknown. Let me make it three unknowns. Let's see if it works out. A plus bx raised to power of n. So now over here, let me write it down. That should be nc0, nc1, and nc2. And over here, let me write this thing, that is bx, that is bx power 0, bx power 1, bx power 2. And the next one, that is this thing, which is a power n, a power n minus 1, and this thing. So now a and b, let me just grab a question which was there initially. Hold for a second so that there is no mistake. This is P1, this is series, this is APGP, the homework review, or maybe the basic thing. So APGP, I think it was new or something. Let me just date, exercise B, GP, exercise C. There was a question. My bad. It was binomial. So this is series binomial. And I think it should lie in the C. Yes. Yes, that's the question. That's the one that you people are referring to. Okay, the last question. That is something like this. So the first three terms are this: 1 plus ax raised to power of n. That should be nc0, ax power 0, which is 1, nc1, ax power 1, and then nc2, ax power 2. nc0 is 1, ax power 1, nc1 is n over 1. This is ax. This is n minus 1, 2 into 1, a square, x square. Now let me gather the terms. So now first of all, this 36, this is n into a. And this is 576, that is n minus 1 into 2 into 1 into a square. That is the thing. So now over here, the first equation, that is NA is equals to 36. That's one equation. That's the one that you people were asking for. And then n minus 1 over 2 into 1 into a square, that is equals to 576. That is equation number 2. How do you expand? You expand it using the normal way. NC0 ax power 0, NC1 ax power 1, NC2 ax power 2. And this thing was already explained. NC1 is n into a, n in over 1. So remember this thing. That is NC1 is n over 1. NC2 is n minus 1 over 2 into 1. NC3, that is n minus 1, n minus 2 over 3 into 2 into 1. So now over here, make n the subject, or let's make a the subject. That is 36 over n. And then n minus 1 over 2 into a squared, that is 36 over n. 36 over n is equals to 576. Okay, let's start the cancellation process. This n cancels out. And this take 2 on that side. So 576 divide into 2. And this is 36 into 36. So now I have to remove this thing and then multiply. So now I can do this thing that let me just remove the 2. So 2 ones are and 2 18s are 18 into 36. 18 into 36, that is 648. So therefore 648 n minus 648 is equals to 576 n. And 648 and 576, what's the difference? That is 72. So therefore, let's double check this thing. This is 1836 n 576 n minus 1. And this is all positive. So 576 into n, and this is 72n, that is equals to 576. So 576 divided by 72, that is 8. So n comes out to be 8. I'm slightly skeptical. N comes out to be 9. That is 576n. That is this much. Okay. This is 648. My bad. This is 648. So therefore, this comes out to be n. Okay. So now let me write it. So n is 9. That is this answer. A is 36 over 9. That comes out to be 4. And that is that final thing. So, Alhamdulillah, all good. Have a good look at this. So all done and dusted. Wish you the best of luck. Lots of dua for you people. So people, take care. And inshallah ta'ala, you all people will do wonders. But the main thing is that the last tip that I should give you, that is this thing, which is just sleep well. And sleep well. No more studies. Yes, fractions are supreme. Always focus on them. Fractions are beautiful and fractions are exact. And inshallah ta'ala, that is the kind of paper that you people will be rocking tomorrow, 970912 May, June 2026. Lots of dua for you. Inshallah ta'ala, aap log bhi dua kijega. And inshallah ta'ala, just take care. I am tired. You people are tired. And bhai, so jao. That's what Zany Gamer Boy said. ठीक है? Take care, everyone. Allah Hafiz. नो स्लीप, खुदा न खास्ता खराब होगा तो प्लीज 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 स्लीप कीजिएगा. अल्लाह हाफिज इंशाल्लाह.